A very good morning to all the dignitaries present here. I, Shishira Shetty from the Computer Science and Engineering Department would like to welcome you all to the second International Conference on Data Analytics and Learning 2022. I am profoundly delighted to take an opportunity to introduce the session chairperson for the morning, Dr. M. Sharmila Kumari and Dr. Manjuna HR. Firstly, diving into Dr. Sharmila Kumari's education and interest, ma'am has obtained BE in Electronics and Communication from MCE, Hassan, Karnataka in 2024. During 2001 and 2002, ma'am worked in the Department of Computer Science and Engineering as a lecturer in Mangalore University. Since 2004, ma'am worked as a lecturer, senior lecturer, assistant professor, associate professor, and currently she is working as a professor and head of the Department of Computer Science and Engineering and Information Science and Engineering in PA College of Engineering, Mangalore. Ma'am has received PhD degree in Computer Science and Technology from PG Department of Studies and Research in Computer Science, Mangalore University. Ma'am is specialized in pattern recognition, image processing, IoT, and AIML. Ma'am has published nearly 65 articles in international and national level journals and conferences. Ma'am has successfully completed a collaborative 3 major research projects with Moscow State University, Russia, and also an international workshop on emerging application of computer vision in Moscow State University. Apart from academics and research, as an administrative responsibility, currently ma'am is working as vice principal of the college and also served as an LIC member of VTU, worked as a member of Board of Examination of Mangalore University VTU, member of Board of Studies of MIJAR, St. Joseph Engineering College, and so on. It's our pleasure to have you, ma'am. Now I request our actuary, Dr. Manjuna Kotari, sir, to gloriously welcome Dr. Sharmila Kumari. We also have another esteemed dignitary, Dr. Manjuna HR, who is a senior assistant professor in AIET. He has completed his MTech in 2007 in BEC, Bagalkot. He has teaching experience of 17 plus years. He has experienced many glitters in his life. I wholeheartedly welcome you, sir. Now we will start with the paper presentation team. So rules being like, the presentation will be for 12 minutes, question and answer session for 3 minutes, and the warning bell is given at the 10th minute within which you have to complete your presentation. So now I request paper ID 37 with the title Comparative Analysis of Generic Outlier Detection Techniques to go on with your presentation. And I request paper ID 29 to be ready.
Very good morning to all of you. I am Vasudev Kinti, a 4th-year student from MIT Manipal, and I will be presenting on the topic Comparative Analysis of Generic Outlier Detection Techniques. What exactly is an outlier or an anomaly? So, an anomaly or an outlier is referred to as a point that deviates from standard behavior of pattern, something that doesn't follow the norm. And anomaly detection or outlier analysis is the process to detect anomalies or outliers. Why is it important? Anomalous data can indicate critical incidents such as a technical glitch or potential opportunities for improvement. Thinking is something like it is really useful for process automation and forecasting and predicting events in the future. So this, in any kind of ecosystem, anomaly detection is very important because it can impact the productivity. Okay. In any kind of a system, anomaly detection is super important because it can impact the productivity of the system and it can impact the revenue of a system, especially in a business perspective or an industry perspective. So it is really important that outliers are detected as early as possible, and so that preventive maintenance, process automation, and forecasting and predicting events in the future can be done as early as possible. How can we classify anomalies? Anomalies can be mainly classified into three parts: point anomalies, context anomalies, and collective anomalies. The names are very straightforward. Point anomalies as in a singular point that is different from it behaves in standard behavior. Contextual anomalies as in it behaves differently under a specific context. It can be in location, time, or any other context for that matter. And collective anomalies when a collection of data exhibits anomalous behavior under a certain conditions. So for our research, we have used three data sets. The first all three are multivariate, and the first two ones are available online. And the third one is a subset of an industry data set. It's a much bigger data set. But for the purpose of simplicity, we have taken a subset of it so that computation becomes faster. Before we apply anything on the data set, cleaning is very necessary because there can be data redundancies, there can be impurities, so exploration of the data has to be done before we apply any kind of algorithm. So if there are missing values, that has to be taken care of, and if there is redundancy, that too has to be taken care of. We need to have a good understanding of the data set before we apply anything. So data exploration to understand the spread of the data, distribution of the data, to understand the upper, lower quartile, the mean, median, mode, and to have a deep, good understanding between relationships between attributes. Like if we have a system where there are certain sensors, so something like the temperature could be related to pressure. So we can do different kinds of plots to understand the relationship between different attributes and the relationship between all attributes as well using time plots. So the first algorithm that we do is k-nearest neighbor algorithm, a very simple algorithm. The basic understanding is that it determines the nature of a certain point based on how its neighbors are classified. So if you're guessing the color of a car, it is decided by the colors of its neighboring cars, because that's how it works in our data set. So different formula can be applied to identify the one in cosby distance or Euclidean distance for it to be made. So this is the model that we got for the second data set. So there are different clusters, and the yellow ones are anomalies that are detected by the KNN algorithm, and the blue ones are part of this point. At least it's very clear that the yellow ones don't appear to be a part of the cluster, so it is really visually understandable that they are anomalous in nature. The main advantage of using KNN for anomaly detection is that there is no training. So even though it doesn't learn anything. So even though there is training phase, it's effectively no training at all. So because of that, seamless data can be added. So since KNN algorithm doesn't need training to be training before producing predictions, new data can be supplied seamlessly without disrupting the system's accuracy. And it's very simple to understand, it's not very difficult. A major disadvantage of this can be that for every single data point, you have to calculate the distance with every other point. So it can be computationally straining, and it may be complex with a very large data set. And since our data has a large dimension, that is, it's multivariate, like 9 or 10 columns, it can be difficult to do with data of larger dimensions. It's also sensitive to data noise, but this can be taken care of by data pre-processing. As in, we have taken care of outlier, redundancy and missing data, where we have taken care of data pre-processing. The next one is Gaussian mixture model. So in Gaussian mixture model is a probabilistic clustering model that assumes that each data point is a part of the Gaussian distribution. So data points in low density areas in the GMM are classified as anomalous data points. This is mainly useful in the case of in data sets where there are hidden or unobservable parameters, and we don't really have a good understanding of the data set. So it's also useful when a point has mixed membership, as in when we don't understand the data set at all, and a point can be a part of more than one cluster. So, which is not possible in many other traditional models. A major drawback is that to have a really good GNN model, there needs to be a lot of data and there need a lot of iterations have to be performed. The third one is isolation forest. So it is based on decision trees. The simple idea behind this is that we have data to be partitioned based on certain conditions or certain features. And every time this is done, simple understanding for a 2D data set can do this. Data is partitioned based on a certain feature, and every subset is partitioned until we reach maximum depth, or there is no more partitioning to be done. In this case, the samples or the data points that travel deeper into the tree are less likely to be anomalous, which means they are part of a cluster. And the data sets that are seeded higher into the tree are more likely to be anomalous because they are not a part of the cluster. How does it work? In isolation forests, partitions are created by randomly selected a feature within the range of minimum and maximum, and once the root node is selected at random, and then for each subtree, the same action is performed until we reach until all the data points are seeded, or we reach a maximum depth. Once this is performed multiple times, when we reach the average height of a point in a tree called E of h of x. And based on E of h of x, for every single data point, S is calculated. S is known as the anomaly score. It is also dependent upon C of n, which is called as a normalization constant and is dependent upon the total size. So the simple understanding of this is that for every single data point, we calculate what's known as the average height in the tree. And based on the average height in the decision tree, anomaly score is calculated. And based on the anomaly score, it's decided whether the point is a normal point or an anomalous point. So there are three criteria. If it is closer to 1, it is more likely to be an anomaly. If it is less than 0.5, it is almost surely not anomalous. And if it is between 0.5 and 1, whichever one is closer to, that's how it's decided whether it's an anomalous point or not. So this is the model for the same data set, but with isolation forest, whether it is an anomalous point or not. So yellow is anomalous, and blue is a major advantage is that, like KNN, there is no calculation for distance or it's not a very computationally straining. So there is no distance or density measures at all. And a small size can perform regression. It's not like it complexity increases. Since it takes more trust to extract anomalies in a cluster, there's also a point that we don't have to see every point in the tree until we reach a maximum depth. So it doesn't increase the complexity that much. We can define a maximum depth in the tree so that we don't have to perform computations till every point is seeded. We can stop at some point so that the complexity doesn't exceed. A major disadvantage in this is that the system is very biased. So it is biased on the way the branching takes place, and also the contamination parameter that needs to be provided by training the model. That is, we define what percentage of our data is contaminated. Yeah, so this is our result. Even though we get that isolation forest can detect more anomalous points, the major point is how we can improve it in a better way. So it's using the concept of extended isolation forest, which takes care of improving the anomaly score. So we saw that anomaly score is being calculated based on E of h of x, which is the average height of a point in the tree. So that can be improved in the case of extended isolation forest. So I don't know if it's visible properly here. This is the standard isolation forest, and that is the extended isolation forest. So there are some spots. So yellow is in low anomaly scores, and red is in higher anomaly scores. So even though there are points only in this region, there are some regions with slightly lesser coloring. So that is because of the contamination parameter or the bias in which the branching takes place. That is handled in the case of extended isolation forest. Thank you.
Thank you for your good presentation. So I need some clarification about from where you collected data set. Is it a standard data set or your data sets?
The first two ones are available online. And the third one is a subset of an industry data set.
What is the size of the data set?
The first two ones are very small. The third one has like 9 line columns. 3 to 1 is subset.
Yeah, we cannot.
What it is?
No, we cannot disclose the data. From that point of view, only we have taken only 2,000 rows and 10 columns of the data. We have actually 10 lakh this one rows of the data.
Okay, the industry
Data, yeah, because we have signed an agreement.
Okay. So you proposed algorithm here isolation forest. So that is compared with recently proposed novel algorithms. What are those two algorithms? You compared with this iForest. Okay, that is with the recently proposed novel algorithms. Okay, so how you compare? So what are the?
So we got the result, the number of anomalies detected. But the way to actually compare would be to see how the anomalies score compute calculations being improved. So that is in the case of extended.
Why I asked that question? You told it is for smaller data set.
Yeah.
Okay, smaller size, it is working better.
Yeah.
So for larger data set,
Larger data set.
complexity, yes, obviously it will be increased.
It will be increased, but there is a clause of maximum depth in that. So it doesn't increase to an extent that it affects the efficiency of the algorithm. So we can define what's known as the maximum depth. After, for example, if there's a cluster that is very dense,
Yes.
there is no point in seeding every point because it's in a cluster, there is no anomalous point. So we can define what's known as the maximum depth. There is no point in seeding all the points in the cluster. It's already in a cluster, so it's not going to be an anomaly.
Okay. Fine. Thank you.
So how this clustering is done here?
All the three algorithms will add to clustering.
So what data pre-processing is done?
So in our case, the data redundancy can be handled. There's repetitive data. And we are dealing with only time series data. So we can identify which rows are missing. Like for every second or every minute there's one data from 9 sensors or 10 sensors. So if there's a missing data, we can actually identify. We had certain conditions like if there was 5 consecutive missing, then we can fill it with zeros, or we can fill it with the average of the previous few values. So according to certain conditions, either missing values or redundancy.
Thank you.
Other than anomaly score, any other parameters considered to evaluate performance of the system? Your system.
In the case of isolation forest, you can see only anomaly scores. But in the other ones, for KNL or something, it only detects whether it's anomalies or not.
Thank you. So open to the audience.
So you can tell about extended isolation, the comparison in very short point.
So the thing is, the standard isolation forest, the partition is happening perpendicular. So actually, this is the reason there is some kind of bias when you into this. Because the partitioning is happening perpendicular, so there is a formation of those regions of. Actually, there are no points over here, so the anomaly score should be red, just like this. So because the standard isolation forest has partitioning in perpendicular fashion, like this. So there's a formula for this. It happens because the dot product should be 0. Since the dot product should be 0, the line should be perpendicular to the other line. So that's why it's happening over here. In the case of extended isolation forest, the formula will be less than or equal to 0. So it can be the next partition can be formed at a random intercept and random slope. So that improves the efficiency of this algorithm in the case of external.
Thank you, sir. Now I request paper ID 29 with the title Handwritten Word Recognition in JPEG Compressed Domain using CNN by LSTM network to go on with the topic.
Good morning, everyone. Good morning, everyone. My name is Dept. Here, I am going to present HWRC net paper ID 29. These are the folders to learn this. Myself, Ayushar, and Professor Mohammed. Okay, so we are coming basic problem statement. What is the DCT, compressed domain, and which paper do we refer with this algorithm? What is our proposed methodology, and what library use for implement this method, and what data set we are using, and the comparative relation and results. So first, starting with introduction, mainly handword recognition is a beneficial model to understand the text present at the source, like in the paper documents, photographs, screen, and other devices. So what is the scope of this model? If we have a large handwritten documents, so we can visualize them, we can extract data from the forms, we can also do the handwritten biometric recognition, and also can read the check amounts. So what is the problem statement? Like handwritten word recognition is a traditional problem. So previously CNN RNN model is a effective model to recognize handwritten word. So we are going to modify it because it is doing in the pixel domain. The computational cost for training this model is very high. So we are training this model in the DCT domain, direct cosine transform. So after transforming in the DCT, the size of the data set also decreased, and also the computational cost is also decreased in this case. So why DCT? Why we choose the DCT? DCT is a common transformation we use in the compressed domain. The sparsity of the DCT is also high because the high percentage of the zero coefficient. Robustness of the noise, like most of the noise happens to the high frequency, and in the DCT transformation, the high frequency is going to be ignored. That frequency is increased because DCT has the coefficient value, so it is easy to compute rather than the pixel domain. But also in the DCT transformation, we lose some sort of the information from the image. So image quality going to be decreased, which can affect the performance of the. So this is DCT domain. DCT domain also has some sort of the visual feature. The lowest frequency coefficient represent the overall structure of the image, and the higher frequency coefficient represent the fine detail and the texture of the image. So the relative importance of the different frequency mainly influenced by the quantization process. Important components assigned the higher precision, and the less important components being assigned the lower precision. So this allows the compressed signal to maintain a good balance between the quality and the compression. So which paper do we refer? The first paper is mainly trained over the AIET system, which has a 95% accuracy rate, but the data set they use, it has only one writer. That is only one writer, so it is not a robust model. The second paper we refer is the CNN RNA with the CTC layer, which have a accuracy of 90.3% character accuracy with IAM database. In third, we also want to explore some papers which have a compressed domain. So this paper have a model which can in a compressed domain, but it is basically trained for the content-based image retriever. In the last paper, we need some sort of the decoder in the to after labeling we need to decode those labels. So we have to define which decoder we are going to use. So we refer this paper. It is written by the Squirrel et al. What we are going to propose in this paper, the first we have an handwritten text. So we pre-process this image and going to convert in the DCT domain. And after converting into the DCT domain, we are feeding this image into CNN model. After that, we are going to labeling these characters through RNN. And after labeling, we are going to decode it using the CTC decoder. After the CTC, we get the expected text at the last. So, what pre-processing technique we are used? First, we do the contrast testing. Then we do some morphological operation. Here in the case, we do erosion. As you can see, after erosion, there is some black parts are increases and blurred. And after that, we transpose that image to feed into a CNN model, because CNN model CNN model the row-wise computation, so we have to transpose it. After pre-processing, we did image compression into a DCT domain. After that, we use CNN. In CNN, we use 5 layers. The first 2 layers is a kernel of 5 cross 5, and the last 2 layers is kernel of 3 cross 3. After each layer, we did value operation along with the pooling layer. And after CNN, as a RNN, we use the bi-LSTM, the traditional RNN model have a lot of the parallel computation. So bi-LSTM is a good way to labeling this instead of the RNN. So we use bi-LSTM along with the CTC to decode those labeling. CTC decoder. We also refer this decoder in one of the paper which is recently published, where previously decoding happened using the dictionary-based system, where we have a word and we are going to feed into a dictionary what is the best word possible from this lab. So they mostly use the dictionary system which have a higher cost of computation. So we use this CTC decoder which have a based structure where each node have a two state. Either it is a perfect word or it is not in an English dictionary. So here you can see A is a perfect word in the English dictionary. And also T is not a perfect word for in the English dictionary. In the further you can see the 2 and 2, which is a perfect word for in the English dictionary. What is our model architecture? We have a compressed DCT domain image. We are going to feed into a CNF for the feature extraction. Then we have a 256 feature with a 32 timestamp. We are going to feed this multi-feature extraction into a LSTM layer, which is a bi-LSTM. We have the forward LSTM and also backward, because the word have a context in the forward and backward. Like a tweet, like after in English grammar we have some sort of like you, we always get you in next, and also some of the relation in backward system. So we use the bi-LSTM for the identifying this. Then after training RNN, we did use the CTC decoder. After we calculate the loss and feed into a next best for the next batch of the years. The library is using in this system TensorFlow, LMDB, M5, OpenCV. This is a general library. We did use edit distance for the calculating error. Dataset, we use the IM dataset. It is written by 657 writers. It has 1539 pages and 30k around 30k level text. And it is generally published in 2000. It is an error plot where we compare the word accuracy, word error rate and the factor error rate. The factor error rate in the pixel domain is high, but in compressed domain we lose some, like we have a less accuracy, but the computational cost time taken, the computational cost is less in the compressed domain. This is the same result which we saw in the graph. This is the result, like here we like where we try to test this with our handwritten text. So here is some of the words which recognized by the model. Conclusion, like they for training purpose we can use the DCD domain for the handwritten text organization. It may increase the error rate a little bit, but we can save the computational cost by converting it to a DCD domain. There is the order. Thank you.
Thank you for your nice presentation. So I need some clarification from you. Okay. Even why you go with compressed domain? Anyway, that machine learning techniques are you using?
Yeah, like we go with DCD because like it is the most common method used in the compressed image, like for compressing the image, like JPG compression or MPEG compression. They all use the DCD transformation in the process. Okay, so like when we are if we train the model in the DCD domain, so when we are feeding the text, so we don't have to invert the DCD to found a result, right? So like we can skip one part of the computation even in the model itself.
Don't you think it will affect accuracy?
Yeah,
It is lossy compression technique, right?
yeah, it is a lossy compression, right? But we can save the computational cost by that. Like the accuracy is not, we are not looking at accuracy as much because DCD have itself a visual feature. You can see here. This one, like we display in the simple model which has a character error rate of 9.89, but in the 4 cross 4 we have character accuracy, character error rate of 13.89. So yeah, we did lose some accuracy, but we like computational cost is literally half of the what we pay in the CR in the simulation.
Okay. So usually, we concentrate on accuracy to get better accuracy. Every time we are concentrating on getting better accuracy, right? While designing and developing any new proposed algorithms. But why you are concentrating? You are not concentrating on accuracy because for speed we are having now sufficient hardware devices. Okay, now we are not no need to worry about speed, but we always worry about accuracy. But you are telling
we can compare the result of that also because the previous CNN RNA architecture which we have that has a character error of 11.08, but for this model we train in the pixel domain also, so we get the accuracy of 9.85. Attention SDR have character rate of 6.50 but this one have trained over handwritten text which is written by only one line. So it may it is the second model is not robust, but IWRC9 is the robust, more robust.
Okay, conducted experimentation on standard data set.
Yeah, I understand.
Standard.
Yeah.
May I know what is the size of the data set? Size of your data set?
It is around 10 GB.
10 GB.
Yeah.
Fine. Thank you.
See, what is the advantage of finding this DCT coefficient in every small unit?
What is that?
What is the advantage of finding this DCT coefficient for every small unit?
What is the advantage of converting into DC?
Yes.
Right.
The coefficient you are finding, or DCT coefficients.
DCP code, right?
Yeah.
Okay, pixel domain, when we capture the image, we have a pixels of that, right? So when we want to save or compress that image, we have some sort of the quantization process. So we don't quantize that pixels. We have to need some coefficient to quantize this process, like how much frequency of that pixel it has, right? So that coefficient process, like direct cosine transform, right? So we need that coefficient. That coefficient comes from the DCT domain.
So what kind of learning takes place here?
What kind of learning? We can train some sort of model in DCT
I
domain.
mean to say whether it is a supervised or unsupervised learning.
It is a supervised because it is all level text. So we are feeding level text here. We have image and alongside what is the true value or absolute truth of that text. So we are comparing. It is an expected word, and we are comparing with the actual text. And what is the difference between those texts we are feeding into a text? So it is a supervised.
Okay, thank you.
Thank you, sir. Now I request paper ID 38 with the title Artificial Intelligence Based Smart Door with a Face Mask Detection. Present the topic.
Myself, Dept, Scientist and Engineer Established Bangalore, and I'm going to present working of the project AI-based smart metal face mask detection. These are the contents: introduction about the project and objectives, design phases, algorithm of use for implementation part of the project, and conclusion and future work. So as we all came across the pandemic situation in the past 2 years, being healthy plays an important role in everybody's life. So we need face masks which are placing a very important role and which is essential to protect ourselves and our family members. So despite knowing this, people tend not to wear masks in the public places such as air terminals, shopping centers, etc. This may affect the other people. So the solution for this problem may be designing a smart device which will detect the face mask in public places. So this smart device can be inserted in the entry point of any public places so that the people can prevent themselves from the pandemic situations. So objective of this project is to develop a smart door that can accurately detect mask over the face and to allow entry only for the people who are wearing masks to the public places, so that we can curtail the spread of coronavirus and thereby contributing to the public health care. So this proposed system allows for facial recognition and classifies images of people with mask and without mask and gives the output based on this classification. So this is the architectural diagram. We take the input as a face, read the face, and for this face we are applying feature extraction techniques, maybe position features or color features, and this is applied to the classification. The main algorithm used for classification here is the mobile and V2. And after classification, the image is compared with the trained data set images, that is with mask and without mask. Based on this output, we are going to predict the output with mask and without mask images. So based on the prediction, we will trigger the relay. We have two types of relay. Relay is high and relay is low. So based on this relay, we have the output, that is the result. The device will open the door or closes the door. If the person or the image is having a mask, then it opens the door. If the person is not wearing a mask, it closes the door. So this is the design of the data flow diagram. Starts with capturing the image, that is a visual input, and this is followed by a data collection, that is feature extraction from the captured images. The features are classified based on the mobile net, and we predict the images, that is the output as the mask, with the mask as well as without mask, and this goes to the output system. And other side we have the data set, and the data set is pre-processed, and this is given to the classification, and we compare the data set image with the extracted image, that is a captured image, and then we predict the output as with mask and without mask. So this is the algorithm for logic implementation, that is input, and this input image is given to the mobile net V2, which is followed by layers of array of layers, and this mobile net V2 output is subjected to the average pooling. From this average pooling, we extract the similarities, and the images are flattened to get the fully connected layers, and we get the output, and this output is subjected to or sent to the Raspberry Pi embedded system. From this Raspberry Pi, IoT controlled entry system is enabled, that is opening the door or closing the door. So this is the implementation part is done. So my students have used a webcam to capture the image, and this image is extracted, and it is allowed to enter for feature extraction and the classification. And from this classification output, the output image is transmitted to the Raspberry Pi. That is, from this Raspberry Pi, the relay is triggered, that is on or off. If the relay is on, again they have used one more DC motor. If the relay is on, the DC motor will rotate in one direction. If the DC motor rotates in one direction, the door opens, and after a delay of 2 seconds, the door automatically closes. Suppose if the relay output is low, the Raspberry Pi sends a low value, and the door will not open. This is the implementation part. Conclusion and future scope. So this manual detection of face mask, we found it is very expensive, time consuming and inconsistent. So the facial recognition technology and this solution which replaces the manual work, and this is developed to come up with an efficient way of restricting people who do not follow the COVID-19 safety protocols. So future works may be included like integration of physical distancing, where the camera detects the person wearing a face mask and not wearing a face mask, and calculate the distance between these two people who are wearing masks and who do not wear the mask, and give an alarm for the people who are not wearing masks, just to avoid the physical distancing in the public places. Thank you.
How many samples are taken for experimentation?
They took around 1,500 samples they have taken.
1,500 samples.
1,500 samples they took.
It's real time, right?
It's not real. Data set was 1,500. You just have to go in front of the webcam. They take the.
So like 1,500 people.
No. That is real time. Implementation was real time. Data set.
You conducted experimentation on the standard data set also. Where is the result?
Result I have not.
Okay. So what are the other deep learning algorithms you compared? It is only implementation.
Yeah, only implementation. Comparison was not
Not
done.
done.
Implementation part.
Okay. So your system will address the problem of occlusion.
Yeah.
Any other challenges it will address, like orientation?
This is only detecting the face mask, whether the person is wearing the face mask or not. Based on that, it will open the.
Okay, if it is a presentation spoof, for example, the entire face is covered with, for example, my face. Okay, same, his face mask is I am wearing. So in that case, what happens?
The door is not open now. It is covered fully.
But you are showing only that portion of the face is covered. If your entire face is covered, it is incorrect detection. Did you connect
That's why the door will not open it actually. Only the mask, only this portion it covers and it will detect and compare it to only face mask, not the entire face.
See, my face is already, if it is genuine, it is already stored in the database. Sir is coming with my face mask. He will enter. Okay. What is your system? What it will do? For example, see my genuine that is already stored in the database as a Sharmila. Okay. Sir will enter. Okay. So he will take the mask of the same my face mask. Okay, he is wearing, he will enter the system. Okay, your the place.
You are saying only face mask?
Yeah, spoofing.
Okay. So in that case, it will not open the door.
So just for my clarification, whether it is addressing that problem, okay, that challenge or not, just.
Just a challenge.
Okay, thank you.
Does it work for video images?
No, sir. Only for images.
For static?
Yeah, static images.
Is there any alternative for Raspberry Pi?
We can use, but we
There
have.
are other boards also.
Yeah, we can use.
Which are the other boards?
Yeah, we have not tried that.
Already.
Already we can use.
So, what is the difference between Arduino and Raspberry Pi? Because Raspberry Pi is not clear when compared to Arduino.
We can use.
Why you are choosing this Raspberry Pi? Any
No
specific
specific
reason?
reason that we have chosen. We have just used. We are not compared.
But what is this average pooling? I mean, average
It's
pooling
part
is
of convolutional neural network, mobile VNet. That is array of images. That image is compressed into array, and that is passed to the average pooling. You have got several layers in that. So that layers are compressed and get a one layer, flattened image. Just to flatten the image we are using that. So this technology of the mobile VNet.
What is any reason why you used that average pooling? Any other pooling techniques are there?
Yeah, we can use, we are not compared.
Not compared. So you could have tried.
Yeah.
Maybe the different deep learning concepts as well as they also pooling technique. Thank you.
Thank you, ma'am. Now I request paper ID 39 with the title Script Identification based on Pre-trained Clustering and Neural Network Models to present the topic, which will be in online mode. Paper ID 39.
Good morning. I'm Dr. Suthola Silva. I teach in Pajikos College of Engineering.
Online mode.
University. My co-author is Dr. D.S. Hanimat, who also teaches as a professor in KIDs in MIJAR University. Okay, the topic I was going to talk about is script proof based on built-in clustering and neural network, which is used to identify the script, different scripts that are written. The process that I will be going about will be explaining, will be the contents, that is abstract, introduction, literature review, proposed system, conclusion, and then reference system.
Excuse me, madam. Can you make it
We know object
slideshow?
identification is a process to recognize an object in an image.
Slideshow.
So whichever object you want to recognize, you abstract it from the remaining part of the image. So the technique has to be used to extract it so that the outline is kept properly. As you know, an image consists of a large number of objects. The important object or the object which is of your interest has to be extracted from the background. So segmentation technique is used to separate the object from the image, preserving its outline. Segmented object is then on the back to extract features and then you map it and then you try to recognize. So the main methods that are used efficiently in applications such as script recognition, image database lookup, fault detection, and image editing. Introduction. Your script identification is an optical character recognition which converts data and written text into machine editable text. So the main thing is the optical characters are converted into digital characters, and identification is a process to make the network learn, comprehend, improve, and interpret the written or printed characters. So the written or printed characters, we have taken the data set is in English or Marathi. We have taken we made our own data set, which is over 2,000 data images, which are taken from different people, like it's written or they are taken from public boards or from e-plays and things like that. So this process is useful in interpreting brand checks or distinguishing the script written in all application forms, maybe job application or students applications, etc. The literature review. Frank Shea and Xiaochan Zhang in his work proposed seed region drawing method for color image segmentation. So it was an ideal for segmenting image into regions such that the property of components of region mean exactly in one seed. So in region-based segmentation, the image is segmented to multiple regions of interest, and to recognize the object, there is a need to analyze all the regions which are of interest and join them together to form the object of interest. So instead of doing such multiple regions, we would suggest that it would be better if we could extract an object from the image for recognition. So that's what we have done. The proposed one is similar to the previous one, but the object is extracted from the image or from the background. By using k-means, we have used hierarchical clustering, and we have used also fuzzy sequence clustering algorithms. So the segmentation technique separates the object, or in our case, which is a character, from the background, and therefore preserving the outline of the character, and then makes it easy for us to recognize the object or recognize the character. D.T. Lowe in his work proposed an algorithm where scale invariant features transform was used to extract the features. So he used difference of Gaussian function to identify potential interest points. He extracted 128 element 128 features, and the algorithm was robust to scale and rotation invariant, but it failed to identify different instances of the same object. So our proposal was similar, but of course it's computation faster. We have used features like color, shape and texture features, which are more stable, and therefore it has been able to identify all the instances of sound of the same object. Our basic core architecture is like this, where we have digital manuscript, where we collected all the data set for English handwritten and Devanagari handwritten, and from the boards, from public boards, from the gameplays. We have pre-processed the data, the images, that is resize the threshold in basically. Then we have extracted the character from the background, and that's done by different clustering methods like AIET, hierarchical, classicity, and then this extracted image, we extracted the features from it. Like I said, we extracted color, texture, and shape features. Then we used it for training a neural network. Then for testing, we use a tested image and we use it in the neural network to actually find a classification, and that's how to classify. So our proposed framework consists of image acquisition, that is you're collecting of image, and like I said, the images we have collected was English and Devanagari. Then you separate the character from the background, that we use many methods to extract it. Then you extract the features. So features that we have used are color, texture features and shape features. We make a data set of that features. Then you train the neural network, and for classification you use the neural network for match for the respective classes, so that it can be classified as different characters. And so this is actually the flow of how we go in and how we go about. Experimental results, the training accuracy and validation accuracy we produced in events, we got it at an early iteration. When it comes to hierarchical clustering, it was a little late, and when it came to fuzzy segments, the accuracy, training accuracy and validation accuracy was much later. So you can see the accuracy was much later as we kept training it. This was the original image. So the original is a Devanagari script that we had taken. And segmentation, when we took at every iteration for different clusters, so we made case 2 clusters, it will give you. So this is what it gave in clustering 6. Then whenever we put an input, we managed to find out and to classify this as the output. When we put A as the input, we managed to classify as A. This is the sum of the way it was visible. This is the way the output was visible. So then we did a comparative analysis, and in the comparative analysis, when any of these algorithms were used, it gave an accuracy of 92, in hierarchical it gave 93, in fuzzy clustering it gave 68, but when we associated all the algorithm and made a proposed algorithm, it gave us 94% accuracy, which was quite high, and it gave a better accuracy and gave less loss as compared to the other ones. So if you see here the losses, which were when the other algorithms were used, the lowest is when we use the proposed algorithm. So we continue. We require very accurate results when employing a handwritten character recognition system. The proposed associated algorithm had achieved less false positive, less validation loss, and less training loss. So these losses were much lesser, so the accuracy was quite higher. So in detection rate, the proposed method outperformed other algorithms in terms of training and validation accuracy. In fact, the training accuracy of the proposed one was around 94.29%, which was higher than all the other ones. These are the references. Thank you.
Next connection. Can you hear, ma'am? Yes, yes. So how your proposed method is different from SIFT? You are telling it is faster than scaling variant feature transform. Can you elaborate how it is, each key point is described by 128 feature vectors values?
I don't know that 128 is because that was done by another person.
Okay.
I don't know. Yeah, and a study of it in my thesis just published around 4 months back.
Okay. In your technique, it is proposed method, it is reduced.
We just reduce number of features also are reduced with my process. And getting a and if I use a single algorithm and if I check it out, then this is on the side.
We are using that is deep learning techniques, right? That is why it is faster compared
Yes, yes,
in case of traditional machine learning techniques.
yes.
Conventional. Okay. What are the pre-processing? Why we go for pre-processing here, data pre-processing? Because you are using, you conducted experimentation on standard data set, right?
No, I took my own data set, I made my own data set.
Okay.
So I took in fact I removed some was scope and things like that. And you take pictures from big dates or like one dates, where one dates and things like that. So and those are the data set, that's the data set. So we have to reprocess it because of that. I cannot take a standard data set from the lab or reprocess data set.
Okay, that all data sets it is real data set only. Conduct experimentation.
Yes, yes, ma'am.
So did you find this training as well as the testing accuracy separately or only testing accuracy completely?
I don't take it in this case in this web, but I mentioned it. But I would go. But you really need to see your part really I put it in the data. There's no testing, I do the testing data for testing.
Fine, thank you.
Yes. Right, right.
Now I request paper ID 50 with the time pattern analysis using deep convolutional neural network to present the topic, which will go through online mode. Online.
50, right? 50. Paper ID.
Yes, ma'am. 1 minute. I am connecting you to project. Yes, ma'am.
Sorry, I cannot see this. So can I share my screen? So is my screen up? Yeah. Good morning, everyone. So my name is Sumitra, working under the guidance of previous user. So I think I'm Business Department, University of Mysore. So I am here to present a paper titled as Children Asian Growth Rate Pattern Analysis using Deep Convolution Neural Network. So outline of this presentation covers abstract, introduction, communication, proposed model, its description, experimentation methods, conclusion, followed by the results. So the problem is here too. Human face anything hard. Not the person recognition, it not even reach and a said person to work any face recognition to reliably and consistently. Patient should be stable. So, in order to solve the patient system, there are some challenges comes. One is the illumination, expression variation, accuracy frequency, aging, and gender. These are the face recognition system. We are addressing the big problem or the staple face recognition.
Hello, ma'am.
Hello. Is to stable to recognize any face recognition system. Work reliably.
Hello. Madam, can you hear me? Hello.
Sorry.
Can you hear me?
Yes, I can hear you, ma'am.
Okay, ma'am. Can you directly move on to methodology, the proposed method?
Yes, sure.
Thank you.
So, the problem statement and approaches in this work is to we have taken the different facial patches of the face images of children varying from age 1 to 12 years, maintaining the consistency of two consistency. In this method, we have used 10 features based quick extraction of features. And once the feature has been extracted, we have computed a very basic simple distance measure called Euclidean distance measure. Once the Euclidean distance measure is computed, we have identified where is the monotonically increasing in the stable faces means facial patterns to constitute of a child. To work this problem, we have utilized consisting of 44 children, age ranging from 1 year to 12. The consistency that we are preserving two consecutive ages of the same child. This is a proposed methodology. For example, at the age 9 and at age 10, we are doing comparison verification whether these two face images matches at the distance, different distance measures.
For example, if I take the input image and do the preprocessing verification alignment, only the patient component will be extracted. Once the only patient component has been extracted, we have taken the patches, patient patches either in the row basis and even in the column basis patient patches. And we also taken the full face images or also and region and we are making a big comparison between the two consecutive ages of the same child. Once the alignment of frequencies is done, we have extracted the features like alignment, bullet, resonant of different gradient and reach of the gradient. Similarly, insertion and Susan. These are the different pre-trained networks for feature extraction. Once the features are extracted from the pre-trained networks, we have measured the distance between two consecutive ages of the same child. This is the proposed model. And this is how the model looks. This is an internal representation for the AIET network, for example, layer 1 and layer 2, layer 3. How we have computed this convolution neural network as a feature extraction. Because these are pre-trained weights, we have utilized this as a feature extraction, not for the classification, or we are not training the model. This is already existing, nothing. And based on these features, this is the proposed model. To work on this problem, we have created our own data sets. So, we have utilized 614 case images, stand-based images of 42 children from age 1 to 3 years old, regular time of 1 year. So, the difference between the one image to next image to 1 year time lapse. This is the only constraint we are making. So, the photograph we have collected photograph from all possible sources. The only constraint that the child should face the camera with the neutral expression. The different sources like word, these are the different ways we have collected the photos from the parents of the children. We have collected maximum age from 1 to 17 years children's photograph. We have collected both hard-based and soft copies of the photos. And so among 440 images, 42 children were covered, among which 19 are male and 25 are female. This is the statistical description of our data sets. The number of males and females, number of images covered. What is the age range? So here the minimum age is 1 year and the maximum age is 12 years. So average images covered in for all 44 children are 12. So we are taking only each from 1 to 12 years to make the consistency of all. So the methodology is equal number of images from each child is considered, as I said, from 1 to 12 years. We have utilized children 12 face images each. So somehow 528 longitudinal piece images are considered in this work. Euclidean distance measure is computed based on the extracted features from the neural networks. So average of 42 distance measure from 1 to 2 years, monotonically increasing to consecutive ages of the set. So this is the result, different patches of each child. So this is from the patch 1. From all 44 children from 1 to 2 years, we have computed a distance from 1 to 2 years. Similarly, we have computed only between the 2 to 3 years. Similarly, till 11 to 12 years patch 1 of the pre-trained networks. Similarly, patch 2 from 1 to 2 up to 11 to 12 years. Only 2 consecutive are interested.
You have only 2 minutes. Please find us only 2 minutes.
Okay. Similarly for patch 1 and patch 6. So this is the result for full face images from children of 1 to 2 and up to 11 to 12. This is the Euclidean distance measure for all face images extracted from the 10 pre-trained neural network models. So after computation is done, we have performed this model with the kappa correlation method. This is one of the performance measures to identify whether the ground count is exactly matched with the proposed model, because we data sets. We don't have any ground truth to measure the performance. We have utilized our 10 human experts, the one who are doing the image computation, image analysis one. So computer vision part, so we utilize 10 human experts to make a ground truth. Based on that ground truth, we go with the performance of the model, and this is the result for all 10 observer along with the outcome. So conclusion of this study is we have utilized the longitudinal patient for identifying the patient growth rate analysis filter to deploy any face recognition system or any face recognition system to work on that single age. So for that we have utilized several different face patches and also from the deep convolution neural network. Finally, the computer distance measure. They utilize basic simple distance measure. How this problem works for distance measure. We create distance measure have been utilized. An average of 44 children, and we have measured the goodness of the model to utilize this advantage. The data sets have calculated a longitudinal face images of 44 children, exactly 12 face images from each. This is a conclusion. The patient growth pattern from age 3 to 9 years is gradually increasing. Growth rate pattern in children are flat from 8 to 9 years. So we may adopt the recruitment system greater than 9 years. But the problem is that the data set instead of concrete pollution. There is an essential need of data sets. Here, this is a basic. Yes, sir.
Excuse me. Hello?
Yes.
Hello?
Yeah.
Just, madam, thank you for your nice presentation. So I have one query on CPT. You have taken for experimentation ages 1 to 12 years, right?
Yes.
So if it is 13 and above 13?
Madam, our interest is because we have collected only the images from 1 to 20 years, and the experimentation made consistency we have taken only 1 to 12 years. But our research, we also extracted the face images up to 16 years. This is a basic ground truth problem to address our main problem.
Okay.
We have created a large size data sets nearly of 200 GB of 500 children, and we capture the face images in a 30 months duration. 16 years. That is our standard data set.
Okay. Thank you, ma'am. Thank you.
This is another data set. We have also, based on this analysis, we thought that to give any concrete or discrete solution for stable face recognition system, we have an essential data set. Yes, sir. Yeah, thank you.
Now I request Team Paper ID 50 with the title Iris and Face-Based Multimodal Biometric System presented.
Here's the presentation. Okay, directly move to the proposed methodology results.
Good morning, everyone. Myself, Vaishnavi Kulkarni. Currently, I am working as an assistant professor in IIET Institute of Engineering and Technology. So, today I am going to present the paper titled Iris and Face-Based Multimodal Biometric Systems. So, as ma'am said, I'll just slightly move to the proposed methodology. So, this is something that the contents I'm going to discuss. And nothing but introduction. There are two types, nothing but physical and behavioral, two types of biometrics are there. Here in this, I have considered face and iris biometric traits because face can be captured remotely without violating the privacy of the user, and iris are considered because due to its distinct patterns. Not even the identical twins has distinct iris patterns, and not only for the twins, but also each and every individual has different left and right iris patterns. So this is nothing but these are the traits which I have considered in multimodal biometrics. There are so many other traits which are present. And this is the survey. So many researchers proposed so many feature extraction methods, and different levels of fusion are there. One is feature level fusion, score level fusion, and also decision level fusion. Here I have performed feature level fusion and score level fusion. Okay. So different data sets are already used, and also the classifier and chemistry is already mentioned in the survey. So the problem definition is the unimodal biometric system suffers from various hindrances, such as they are very easily vulnerable to the spoof attacks, as well as interclass variations. Okay, so it is better to go for multimodal biometric systems to provide good accuracy and also security. So this is my proposed methodology. Person recognition using iris biometric trait. At first, as you all can see this is a proposed block diagram. First, the visa database is collected, which is already available in the website. So next is iris image pre-processing. The images are resized by 640 by 480 pixels. And next, the iris image is segmented using Dogman's operator. Next, this Dogman's operator. Next, after the segmenting is nothing but, as you all see, this is nothing but the input image. Here, the segmentation is nothing but process of locating or segmenting the iris from an image. This is nothing but the iris segmentation. And Dogman's turbo sheet model is used to convert from polar coordinates to Cartesian coordinates. That is nothing but this shape is in a rectangular shape. Before it will be the circular shape. This is nothing but Dogman's turbo sheet model. And for feature extraction, I have used ResNet 50 model, which is a pre-trained model. It is not used for classification as it is used for feature extraction. It consists of, it takes the image input image. It consists of 3 channels, 224 into 224 into 3. Always it will be in this format itself. And it consists of, as you know, deep learning, convolution layer will be used, softmax layer will be used, and also batch normalization. So many different layers are used. Hidden layers are also, those will be there. This is nothing but deep learning. Each and every model will be having these many layers. Less than 50 is nothing but it is extremely deep with 50 layers. Okay. So next is person recognition using face biometric trait. Here also the visa dataset. Visa dataset is collected means it consists of both iris and face dataset. Both images are available in the visa dataset.
Okay, can you move to your results?
Yes. So this is a VGD16 architecture which I have used for extraction of features from face. It is something but the face detection. After that I have extracted the features. These features are called as deep CNN features.
Did you customize that?
No ma'am, I have used, but I replaced those with my features. This is next is multimodal biometric system using face and iris. Here, first the unimodal face system will be features extracted from face and features extracted from iris. Both features are combined. That is nothing but feature level fusion using averaging rule. Next, after that, individual scores are generated. Here I have used the maximum rule. Maximum rule gives you the final score out of all the scores which are generated. It is nothing but maximum rule. So that is nothing but score level fusion. after that, maximum value among which the maximum score will be there, that will be taken. After that, it is like used for any kind of person. This is nothing but score level fusion. Next is nothing but this results and discussion. So it consists of both visa data set, iris and facial images. Iris and face features were developed for training and testing. And here I have split the data set into 80% and 20%. 80% for training and 20% for testing. So these are the sample images of database. And these are the results.
8 GB, yeah? Go back, system configuration.
8 GB RAM. So RS is nothing but RC curve.
So I have one query. Why you prefer only face and iris? Why can't other
Because
biometric traits?
if I combine
You can use other biometric traits, right?
yeah, it can use some fingerprint, hand, etc.
Why you prefer this?
I can't go for behavioral biometrics because behavior can change, it won't remain constant. Iris means iris has different distinct patterns. If I combine with face, face can be captured easily. It won't violate the privacy of user one. If I combine, see, it is used in military more, where security is more important than surveillance is more important in militaries. Iris will give definite accuracy is provided more. You can't spoof anything related to this iris mode. Face can be spoofed, but when combined with iris, it will be highly secure.
Iris can be right?
No, ma'am. Patterns are different, ma'am. Left and iris patterns are both are different.
Lens, different types of lens.
But patterns which we expect, those are different. No, ma'am. We can't. Lens won't be having those patterns.
Suppose if there are any missing data, how to missing data is managed?
No, sir. I need to work on how to recover missing data. Only.
For example, in MIJAR data is missing, you take the average and the so like any specific metrics.
We can reconstruct the missing data using some algorithms, but I need to see. These are the differences. Thank you.
Thank you, ma'am, for such a wonderful presentation. I thank Dr. Sharmila Kumari, ma'am, for being here. It was a great pleasure to have you, ma'am. I also thank Dr. Manjunath HR, sir, for being here. I request Madhusudan, sir, to present the management.
Good morning, ladies and gentlemen. I, Monica Ella, of Computer Science Department, wholeheartedly welcome you all to the second day of Second International Conference on Data Analytics and Learning 2022. I welcome our Honorable Chief Guest of today's session, Dr. Dinesh M.S., Principal Scientist, Philips, Bengaluru. Dr. Dinesh is a self-directed and effective professional with 19 plus years. Good morning, ladies and gentlemen. I, Monica Ella, of Computer Science Department, wholeheartedly welcome you all to the second day of Second International Conference on Data Analytics and Learning 2022. I welcome our Honorable Chief Guest of today's session, Dr. Dinesh M.S., Principal Scientist at Philips, Bengaluru.
Dr. Dinesh is a self-directed and effective professional with 19 plus years of effective experience in developing artificial intelligence technologies for healthcare industries. He has filed 22 patents and published more than 45 plus technical research papers in machine learning, pattern recognition, and image processing area. Dr. Dinesh was adjunct professor at IIT Allahabad and honorary professor at PET Research MIJAR, University of Mysore. His areas of interest are machine learning for medical images and text data, clinical collaborations, system architecture, computer vision, clinical studies. Dr. Dinesh has also been honored by several awards from Philips, Simons and GS. On behalf of Arvas Education and Foundation, I request Vinay Kumar sir to florally welcome Dr. Dinesh. I extend my warm welcome to the session chair, Professor Karunakar Kotegar, Director, International Affairs, MIT Manipal. Dr. Karunakar is working as a professor and a head in Department of Computer Application, Manipal Institute of Technology, Manipal. He has completed his PhD in 2009 in the areas of scalable video coding and postdoctoral fellowship at AIET Ireland on scalable video streaming over peer-to-peer networks. His research interest includes image processing and communication, scalable video coding, media-aware network elements, and many more. Dr. Karunakar has been associated with IAESTE as a president. He has also served as a deputy director, international collaboration at Manipal Academy of Higher Education. In 2020, Governor of Karnataka nominated him to Mangalore University Syndicate for 3 years. On behalf of Arvas Education and Foundation, I request our HOD to florally welcome Dr. Karunakar Kotegar. I now request Dr. Dinesh to enlighten us about the digital concept and tools for healthcare data analytics. Over to you, sir.
आगे पीछे कैसे ये सब आगे पीछे ये ले सर सेकंड हाँ टर्न
Hi all, good morning. First of all, I'd like to thank the organizer of this conference for inviting me for this lecture. And I also thank the Institute, Arvas Institute for providing this opportunity. Okay, so next around 45 minutes, I'm going to walk you through have any questions, please try to interrupt me in the middle. Even if the session is interactive, I'm okay with that. Okay. With this, I would like to take in this talk, I'm going to cover some of the digital concepts. Like, for example, nowadays there's a lot of data, right? So it's like if you really look at it, the kind of data what we are really generating is quite among us. That's each for example is taking a photo. So in that photo, so there will be some million photos. And similarly, the information overburden is happening. So that is where if we have a data, we need to really derive the actionable insights from it. So having data is not a big deal at all. So you can have a plenty of raw data. So then how will we get a meaningful information out of it? So that is where these kind of digital tools and concepts what we have developed, that would be very useful. And how do we really, in the different digital scenarios, how we can really extract the information and the actionable insights from the data, especially that from the healthcare perspective. So in today's topic, I'm going to talk about the personal health strain. This is one of the health strain concepts developed in Europe, okay, where because of this GDPR, that nowadays the data is becoming quite strict. The privacy aspect, the strict in the sense, the privacy aspect of the data is quite strict. So there is different countries have their own rules and the law and regulations. So how do we really, if you really want to develop an AI model, how do you really respect the law of the land and still develop a kind of a machine learning model? So that is where this kind of personal health strain concept came to picture in Europe, where because the GDPR is a European data protection rule, where they are very strict that data should not leave the hospital. So for our in healthcare applications, the data is quite crucial, right? So if you really want to get actionable insight from the data, we need to design a machine learning algorithm or AI algorithm to derive information out of it. So that is where this the personal health train concept is. They came up with a personal health train concept where I'm going to give a demo. I have one video where the machine learning models are kind of like bodies. We go across, go visit the different hospitals, and then it will learn and then move on. Since on the technology term, we really want to say it's kind of a client-server architecture where the server will be there, and then clients are the hospitals, where the data will be learned from the hospitals, and the machine learning model, the weights will be projected to the server where the weight aggregation happens. We're going to talk more deep into it, and then in that we also have a pay data stations. So that is part of this the health train where it should be paid. I'm going to talk about the paid concept and then the federated learning. So I'm going to talk about how we can do a federated learning, and then on top of it, why do we need all this? We need to develop clinical decision support. Okay. In healthcare, if you really look at the data, can be different types. It can be images, it can be radiographic features, or it can be kind of a patient monitoring data. It can be a 1D signal or a 2D signal, ECG or EG signal, or it can be a medical health record, or it can be the radiology report, the clinical report. So look at the data. The data itself is quite variable, right? So it's variety of data. So because if you look at this image, so the image is can be an image. So how do you get the information, right? For example, anyone can get the images, X-ray images. Any technician can always go get the images, but how do you interpret? Is there any fracture in it, or is there any consolidation? Are there any emphysema, or some kind of comorbidities, the disease comorbidities? So how we can do? So that is where this kind of AI algorithms will be developed. We can really detect those diseases and then generate a kind of actionable insights and then provide it to the doctor, and then doctor can take a kind of call. So now with this kind of variability, how do we really process the data? Then only we can generate a meaningful machine learning model. So otherwise, all right, it's a kind of a black box. It's like the data, it's a giant chamber. So if your data is not proper, whatever the data you feed in, so then accordingly the output will be. So that's why the data preparation is a key thing. So how do we handle this? I'm going to talk more about it later. The personal health science concept, just check whether you can be able to view it. Click on it. So here, in these functors are nothing but hospitals. Okay, these are all the different hospitals, and this is the train, health train, where the machine learning models will be sitting here, and then it will go. And the what it really is, it can be a security gate, because so if they can't allow all the the machine learning models or the access of the hospital data is quite crucial. So that's why this kind of the gating is very important. So then this will move across the different hospitals and learn, and this will move on. Okay, that way whatever the models we get out of this kind of a very mature model. Yeah, then if you don't get it, we move on. Okay. You want?
Personal health management requires increasing amounts of personal data, but today, this personal health training's main goal is connecting health data to make them more usable. Personal health management requires increasing amounts of personal data, but today this information cannot easily be used because the data are produced and managed by various healthcare providers, authorities, and more by citizens themselves. These stakeholders collect and manage their data in different ways, making the data hard to find and use. Furthermore, personal medical information is very privacy sensitive. As a consequence, personal health data cannot be used easily by citizens themselves, by physicians, and by researchers. The personal health train goes to the root of this problem by building fair data stations. Fair protocols ensure that data are findable, accessible, interoperable, and reusable. These data stations are connected by tracks, which are strictly secured and protected. Fair data trains are constantly monitored, and only trains with the appropriate validation may enter a particular station. To secure privacy, every data station has rules. Each data owner has access to his or her secured station and can easily request and control one's personal information. In addition, the owner can set rules for who can access the data and how it may be used. Communities with common interests, like patient societies, can choose to connect and organise their information through umbrella stations. With this access, a researcher can learn, for example, which cancer patients benefit most from novel therapies such as proton therapy. Or a citizen with a specific variant in his genome can be automatically alerted when new research results, insights, or possible risks become available. In this approach, the information is accessible for research, prevention, and education without the data ever leaving the station. With the personal health train, health data becomes available whilst individuals and institutions maintain.
Yeah, so we are closely working with the Maastricht University. So we have Indo-French project. So Philips is a private partner to this Indo-Dutch project, where Indian government and Dutch. So we are closely working with the Maastricht University, where Indian government and Dutch government they got together, and then they funded this project. So here what we have done is, as a pilot study, we have tie-up with Tata Memorial Hospital in Mumbai, and then HCG, Healthcare Global Cancer Hospital in Bangalore, and one Mastro Clinic from Netherlands. So what we have done is we have enabled this concept, and then we have automatically learned the machine learning models. So I am going to show one of the models what we have developed out of this project. Okay, so go to the presentation. Okay. So as we saw in the presentation, so the data should be findable, accessible, interoperable, and reusable. That means, so whenever we get the data, the metadata is very important, because sometimes what happens in medical data, when we do a kind of a CT scan, right? So what is acquisition protocol? So the acquisition protocol can be sometimes what happens, what's the slice thickness, so that's a low dose or a high dose. If you really take the patient in a low dose mode, because whenever we do a screening, we always do it in a low dose mode. Because some of the modalities what we use, X-rays, are harmful to the body. So then what happens if we start using the diagnostic type of quality for frequent use, then there are chances that it might induce a cancer rather than detect it. That is why we need to be very careful. So we're using the data, so X-ray data, because the CT is also made of kind of X-ray, used as X-ray. So that is why we need to be very careful, and that is where this metadata is quite useful. The moment you go with the low dose data, it's a signal to noise ratio. The signal to the noise will increase and signal will be less. And the moment you go for a high, then we need to strike a balance between the signal to noise ratio and the quality of the data. And then it should be accessible. So we need to have a trusted repository. For example, whatever the data we have developed, we came out of this IndoDesk project, and it is publicly accessible data. So many researchers across the world can use that data. So now how can they really access that data? So that's why we should have a trusted repository, and then we need to make sure there should be some entry who is using the data to track the data, and then once we get that, then it will be easily usable. And then interoperable. The knowledge representation is quite key. As I was mentioning, the medical data, it is kind of a variable type, right? It is not only a image data, a text data, a signal. Like it's kind of combination of many type of information. So how do we really extract information? The best way to use the knowledge representation. So we can represent the whole information in the form of a graph, probably in the ontologies. I'm going to talk about those. So the moment we put the data in the ontologies, then it is quite easier to generate the machine learning model or kind of generate the insights out of it. And then it should be reusable. Suppose it kind of it should be of open source license, or make sure that whatever the models we develop, that should also be a kind of open source that can be reusable. So in the majority of the European Commission, because Philips is a European company, so mostly I'm referring to European Commission, where they have clearly mentioned that all the projects, the government sponsored projects are all should follow FAA data principles. So now this is one of the known standards everyone should use, and we are also adopting in Indian government as well. And then I'm just showing the same slide, but changing this by RDF. So how do we represent the data? We can represent this whole data, whether it can be a signal, or it can be electronic text data, or it can be image data, or it can be a features itself, right? So we can represent that in the form of an RDF. So what is that RDF is all about? Is kind of a truth. Probably you must have studied this in your curriculum. So where it talks about the subject, predicate, and object. So here the patient is a subject, and then the object is a lung cancer, and then the predicate is a diagnosis. Okay. And by representing this information in the form of an ontology, that is nothing but the ontology is again combination of this, the predicate, the subject, the object, and then the ontology is about this diagnosis is a kind of ontology where we can really say that this is represented in the form of a standard broad-lex library. There are already a standard libraries available based on the ontologies. You can use those and represent the data. So I'm going to show one example here. So this is a kind of ontology represented for the lung cancer. So where it is already known, it is a kind of a standard where all the brains got together, then they define the standard lung cancer. What are the different type of lung cancers? What are the treatment options? All the information that is available in the form of an ontology. So the moment we say that okay, this patient is suffering from lung cancer, then we can also identify what type of lung cancer is it, and then based on that we can also talk about the treatment options. So that's the advantage of really building this. Okay, one example what I want to show is we took the radiology report, and then we want to check whether the radiology report is of a lung cancer or not. if it is a lung cancer, it's what type of a lung cancer it is. So for that, we have built a kind of ontology, that's RDF we have built. So then for that we have used a unique data set. So where we have used some of the standard ontologies for Snowman, Traplex, and LOAMC. So these are all the ones where people have invested money to define this kind of ontologies for the different disease types. And in US, it is quite common that they should really stick to this kind of process. For example, if someone wants to diagnose some fever, so they should follow the, for that there is an ontology. If anyone joins in the US hospital for the diagnosis, they follow this process. Okay? And so similar way, so these are all the ones what we can also adopt here, and then given the radiology report, what we have done is we have also built the kind of a radio audio. So the way we have done is take the data, do the data cleaning, make sure all the noise are eliminated, and then extract the pieces out of it, and then classify it standard, machine learning approach, where we have extracted the features. It's all based on the text data. And then finally, whether it's a kind of a cancer or a non-cancer, but what kind of, whether it's a lung or a brain, which organ it is, and then if it is an organ, what type of disease, whether it belongs to a cancer, if it is a cancer, then where exactly it will fit in. So this is a kind of open source data. If anyone wants to take up a project, they can always download this unique data set. This is already available, but you need to pass certain exams, okay? So they'll give you some tests and exams. So finish that, download this data, and then you can access the data. If you look at this is how the radiology report appears, and then you need to do the cleaning. You need to make sure that the stemming and the stop works. You clean up everything, okay? So all that you need to do, the comma, abbreviations, all those things you need to remove and then prepare the data. The moment you prepare the data, this is the kind of ontology I was talking about. So if this is a cancer or a disease, so whether it's a primary lung cancer or what type of a cancer is it, mesothelioma or non-small cell lung cancer or a small cell lung cancer or different types, okay? So it can be what are the treatment options? It can be surgery, radiotherapy, chemotherapy, all the information exists here. Okay, and then what we have did, so we took the radiology report and then we checked whether it is a cancer or a lung cancer. So we identified that there was a lung cancer, and then we identified what are the different type of lung cancer, whether it is a non-small or a small cell lung cancer, or whether it's adenocarcinoma, squamous cell carcinoma, or large cell carcinoma. So then this is what we got. This is the one what we have extracted. So finally we mapped this in the report. We have got the words lung cancer and adenocarcinoma. So that means this corresponds to, so what we can do is we can attach the standard ontology, and then accordingly we can derive the treatment options. Okay, so when we really extract the information, we can also represent it in the form of a knowledge graph. So for that we can use a graph DB. This is a kind of database what we can really use. So if there is a header information, this is how we can really represent the data. So this is how the graph, you can represent the whole information in the form of a graph, and then it will be very useful for the deductive reasoning. And then see, the other one is about the diagram header. So each images will be having a header. So each header again we can represent in the form of a graph, and then we can do the query and then do lot of operations out of it. And then this is what I was talking. So if you really store the data in this graph DB, we can do a sparkle query. Okay, and just take a pause here. Okay, so why are we talking about the graph DB? This is one of the digital tools where if you represent the data, so just go back a little bit, okay? What I'm talking about the different type of data sets, right? It can be image data, text data, or a signal data. So if you really want to process what is actually thinking, we are thinking of putting in the form of an RDF and then it's a So then the moment you put it in the RDF, then the normal database you can't really store the information, RDF. So that is why we are talking about this graph DB. This is a kind of database which stores the knowledge graph. And it also gives this kind of information. And you can do a sparkle query for this and then get the meaningful information out of it. But once you do that, how can really this can be useful? So this is a database where you can really put the information, if there is a dicoming image or clinical reports, extract information, put it in the form of RDF and the ontologies, and that can be stored in the form of a graph DB, and then user can do a query and then get the information from it. Okay, so that's how. So what is it we have done here? So the graph DB is there, and everything is there, but you can also use apply the machine learning algorithm and generate the insights out of it, and you can also store that in the form of a database. That way, for example, for the lung cancer, which kind of non-small lung cancer, so what's the option? Radiotherapy is the option. In the radiotherapy, what are the different type of radiotherapy you really want to use, or chemotherapy, all kind of disease information you can really get. There's the disease information and then the prognosis chances, and then you can also learn from the past. For example, if a particular patient is having a cancer type, and then what are the treatment options, what treatment was given to the patient, and how well he recovered, all those information we can get. So based on that, the doctor can really take the call. Okay, that's about then generating the actionable. How some of the tools I talked about, the graph DB, and then how do we really store the data, pair data, principles. Now once you prepare the data and store it in the form of RDF, how we can really generate a machine learning, how can we do a machine learning algorithm, right? That is where this federated learning concept comes into picture. So here, the pair data station is nothing but the needs. For example, I talked about the Tata Memorial Hospital, healthcare global hospitals, and then the Mass Hospital. These are the three hospitals. Each hospital has these pair data. So for example, assume that we have a CT image or a PET CT images, and where the doctors will annotate the region of the cancer region and then the CT there. And then similar way, there are 100 clicks here, 200 clicks here, or 300 clicks here. So then this is the main server. So then what we do? We go, server sends initial weights and script to the hospitals. For example, if you have one model, you need to have an initial model. So once you generate the initial model, and then the initial model weights will be sent to each individual care data station, and then train the model in the hospital. So then the training happens individually. Once the training happens, then the main server will be updated and it will be sent back to the main server. And then this process will repeat. Okay, to and fro it will happen. So once it is matured, so then what you get is a kind of a generalized machine learning model that can be used directly for the clinical decision support system. So what is it we are really doing here? That means we are not taking the data from hospital 1, hospital 2, and hospital 3. So assume that there are 100 patient data available in hospital 1, and 200 in hospital 2, and 300 in the hospital 3. What we are taking only the weights. We are not taking the images or radiology reports from that hospital, because data stays in the hospital. Only the model weights will be sent to the main server. In that way, the main server also has a model. So in that way, what we have is a matured machine learning model. What we get is a matured machine learning model. Okay, so that is about the theoretical concept, right? Then what are the different use cases what we develop? So this is one of the use cases. It's a kind of a stroke classification. So DL-based distributed learning for stroke classification. Here what we are trying to do is, so we are trying to detect from the CT scan, are there any kind of a thrombus, are there any kind of a stroke, right? So that we need to develop. So for that, what we have done, CT volume, this is CT volume we take, contrast enhanced CT volume, and then the bone removal and skull stripping. For example, what happens whenever we do the analysis, we have a skull, right? We need to remove the skull, so we need to remove the bone, we need to prepare the data, we need to clean. So once we clean that, then we do a kind of a maximum intensity projection. It's a kind of a, instead of processing, because each slice is having around 100 to 200 slices, right? For example, each volume has having around 100 to 200 slices, only just for the attending. So in order to reduce the time, what we have done, we have taken the thick slices. So how do we really prepare those? Combine the different small slices, different slices, and then combine them and make a thick slice. That is called maximum intensity projection. And then once we complete that, then we can always do a train Excel model, and then we can always generate a kind of a three class, whether it's average or non-average or a difficult to decide. Okay. So for that, we have designed an inception model. So with that, we were able to achieve a good accuracy of 96% accuracy, overall accuracy we were able to get. And then the other what we did is about the liver segmentation. So in this liver segmentation, it's a multi-phase CT. That means what happens? The liver has both arteries and veins. The moment we inject the contrast, so then what happens? First, suppose assume that this is the ganglion, this is the patient table. The patient will be moved inside, and then when the contrast enters to the arteries, then it will be arterial phase. Then when it enters to the venous phase, it becomes a venous phase, and then after some time we want to study without any contrast. That is a multi-phase. So this is how we do a liver analysis, liver segmentation, in all the 3 phases. Then what we have done, we have done a comparative analysis with federated learning and without federated learning. Okay, this is without federated learning. Individually, we checked what is the performance, and with federated learning, we also checked with the result, because we did this experiment, so there the results are on par. That way, we are able to achieve, even with the federated learning, we were able to get the accuracy of accuracy which is similar to of not using the federated learning, where we are putting all the data in one computer and generating. So that way, that process was good. So here, to summarize this, so paid data station conceptualized machine learning models via federated learning and attempt made to realize the personal health train concept. So these are all the objectives of a very good project, and we are able to achieve all this. Okay, now I'll just take a pause here. Any questions or reflections? I'm happy to hear. Otherwise, I'll move on. Good. Okay, so now I talked about the different digital tools, and then how we can really do, how we really respect the law of the land, and even then we are able to develop a machine learning model for that different digital concept I've talked. Now let's talk about the clinical decision support system itself. So how can we really make use of this data set? So as I mentioned, the clinical decision support system can only act as currently it's only a kind of a secondary leader, it cannot be a final leader or a primary leader. So because you see, human can't replace, computers cannot replace doctors yet, but that may not be true in coming days. But now, at the current scenario, the clinical decision support system is only a kind of a secondary leader, it cannot be a primary leader. And then if you really look at the challenges and the variation, for example, even the different clinical sites follows different protocols. For example, if you go to US, where the FDA processes are very serious, then they say that if you really want to acquire the images, you need to follow the guidelines, where they are very strict on the dose, okay, dose which you use to acquire the images. Whereas in India, we have observed it, okay, so they don't follow very strict, especially with respect to the dose. Okay, so that is where the signal to noise ratio will also vary. How do we manage the signal to noise ratio across the different clinical sites? So that is where the generalization of machine learning model is the key. Okay, and then you can also see that though physiology of the human being is same across globe, but the size will also vary. For example, compare the Chinese individual with respect to the African, obviously the shape will also vary, right? And then the technology we are using artificial intelligence. So for example, the vision application we use linear processing and machine learning. And then we also have different diseases. For example, just take lung. In that, what are the different diseases we have? Emphysema, consolidation, COVID, and whatnot, lung cancer. There are so many types, so many variations. So sometimes the models whatever you develop for lung cancer may not work for the consolidation. So that is a complexity we are handling. So that is where we need to make sure that whatever the machine learning algorithm we develop, it should be disease specific, and then it should be multi-center, and it should be accepted globally. The way we have designed it, so if you have a medical data, so we really don't want to bias a medical expert in the beginning. So we give the medical data to the medical expert, he will do the analysis, and then we'll apply the AI or MLDL algorithm, the output whatever we get, so finally we will take the final diagnosis. Of the workflow of the clinical decision support system. So
So then what we are trying to do is, we are trying to come up with a digital solution where we are putting all this the models in the cloud, and then some of the information will also embed the edge intelligence we do. There are already, whether it can be a smartwatch or a mobile, with which are some of the devices with which you can really acquire the images. For example, it can be a 1D signal or a 1D signal, right? So for example, it can be a sleeping pattern or fitness data. So we can always get those information and then do some kind of initial filtering, data cleanup to this edge intelligence, and then the final model can be deployed in the cloud, and then we can always get the solutions via digital cloud. Especially the 5G is in town now. With that, the latency is less. So because of that, we can always make use of this cloud, and there are a lot of applications that come to the cloud. So with that, I just want to share some of the other applications, legal vision support system applications what we have developed. This is one of the MIJAR project output where we work on the lung gross tumor volume. So here, what happens is, why do we really need this lung gross tumor volume is, suppose if there is a cancer in the lung, the radiotherapist has to do the radiation and kill those cancer cells. So while they are killing the cancer cell, they need to make sure that they should not kill the healthy tissues. How do we really make sure that the radiation therapy, the beam, are focused and kills only the cancer cells and not the surrounding healthy tissues? That is where the dose calculation is quite important. So in order to compute the dose calculation, what we need, the volume of the lung cancer is also quite crucial. So that is why we have designed an algorithm which can really go and automatically contour the lung gross tumor. So truly speaking, it takes around 4 hours of the efforts of the doctors to manually contour them. So in order to avoid that, we have designed a machine learning algorithm which can automatically go and do the contouring. For that, we have used a kind of attention unit architecture DL-based model, where we have used around 222 lung CT volumes. We have used atom optimizer, loss function, dice coefficient, leaky value. So this is for these optimization hyperparameter tuning, we got the best results. Okay, so for example, what you're really seeing is a kind of one data set called intra-observer one data set, so where there are around 5 radiologists who have marked this lung gross tumor volume. Look at this. It is not really matching. There is a variation among the different radiologists the way they have marked. So there is an inter-observer variability. So whereas the right side one, what you get is the algorithm output. So we did a kind of analysis. These are all some of the performance matrix what we have really extracted, such as the dice score, precision, and recount. Which is what we have done is whatever the algorithm we have got. So for that we have estimated the performance matrix with respect to each radiologist. So on average, we got around 0.77 dice score, 0.81, and then we got 0.80. And then we did one more analysis, interesting analysis. Okay. In this interesting analysis, what we have done is how much time the radiologists agree with each other's marking, right? So if you really look at it, this is a kind of a confusion matrix what we have created. This is the 5 radiologists here and the 5 radiologists. The reason why I have used RO is radiation oncologist. Okay. So each radiation oncologist, how much time they are agreeing. We put out a kind of a dice score among themselves in this ground truth. So with respect to our radiologist 1 and radiologist 2, 0.84 time. That means 84% time he will agree with our radiologist 2. With respect to 3 is 87%, and then with respect to the 4 is 85, and then with respect to 5 is 84. So similar, right? If you really do this analysis, almost around 85% of the time, the people agree on each other's marking. Okay, that is that's what we got. So, but when we applied our algorithm, so we were able to achieve around 94% of accuracy on all the agreed marking. Okay, and these are all some of the output what we got with respect to the different lesion size, and still we were able to get the same results. That is and then this is about some of the sample output what we will see here. So in this, what you really see is, see this is the lung cross section of a CT, and this is the ground truth marked by the doctor, and then this is the output what will be generated. So one thing what you really observe here is the shape of this lung will also vary. There is like a lung filled with the fluid, lung effusion is there, but still we were able to achieve detect this segmentation accuracy. And similar way when we really go to the bottom of the heart, and then again the shape will change, so we are able to achieve that. And then the bottom, you can see this is interesting one. Okay, see there is a pouch here. This is about the intestine where it starts, and this is the lung ends. And we were the ground truth is not that we were able to discard this. So our model was able to discard this pouch. And then this is about the gross tumor. We were able to detect this gross tumor volume. But we also have, we can't really claim everything. We are doing all being super good, vanilla, we are all doing good. So there are always disadvantages as well. For example, there is one more small lesion, so we have completely missed that lesion here. So that is where the algorithm training we need to increase, and then we need to have one of the different strategies there. This is about, there's a video here. Yes, just come. This is about the CT volume taken from top to bottom, and then how we have applied the algorithm on, probably don't put in presentation of this. Yes, escape, and then, yeah. So there what we have done is, see this is at each individual slices how this, the lung segmentation model is appearing, right? So that way you can really see, for the whole lung we were able to do this segmentation. Right, move to the next slide. Next slide. Next slide. There's some more. Yeah. Go to the next slide. Yeah. So, yeah. So with this is how the output what we have got, and then you see then that's the summary. The design model was able to segment the lung cross tumor volume, and this approach automatic segmentation, and then yeah, we are trying to this model in our workstation. That's the kind of a post-processing workstation. Yeah. Yeah, and yeah, I think yeah, I'll stop here. Are there any questions? So yeah. So otherwise, yeah, I have many more slides. So probably yeah, we can with time permits. I have we can always go through them. I have different options. You know, if you really want to do a pulmonary embolism. For example, in medical imaging itself, there are many open problems you can really take. It can be a different body part type, whether we take the lung or the colon, and then also pulmonary embolism. This is another interesting point where the thrombus will enter into the pulmonary artery. The moment the thrombus enters into the pulmonary artery region, the catastrophic failure happens. The patient will immediately die. So detecting that is crucial. And then the other one is about the polyp. So polyp is one of the early cancer stage. You can detect the polyp in the early stage. It will be very useful. Sometimes the stool will mask it. So some kind of contrast will be given with that. If you drink, then it will mask, and we can still able to detect the polyp. And then yeah, this is the polyp detection. We need to do the volume estimation and then identify at each individual what is the prognosis chances at different multi-time points. And then this is about the breast cancer detection, and then we need to do detection and classification. And between the left and right breast, there is some kind of symmetry analysis we can do. This is about the PET CT, where we can always put the fluorodex in glucose, see what happens wherever there is a cancer region. The metabolic activity will be very high. When you do inject the FPG tied up with the glucose, then what happens? It will absorb, the glucose will be absorbed by the cancerous region, and it will start emitting the photons. And then we can really track the cancer there. So that's the advantage of using a PET CT. So there it is used for staging the cancer. So you must have seen, right? So many times what happens, people go to the doctor, they always say that, oh, the cancer diagnosed you stage is, they say, right? So that is based on this kind of fertility analysis. And then this is a cardiac echo where you can also always estimate the ejection fraction by identifying the auricles and ventricles, automatically mark them and then compute the ejection fraction of it. And yeah, this is how we need to do. We can design a real algorithm. See, you know what? This problem is still there for so long. The technology, the solution what we are providing is improving day by day. Earlier, the seems like I presented some time back, at that time we used active contours. That is nothing but the state of the image processing technique what we use, but now instead of active contours we are using deer to generate this. Okay, so that way the technology is improving, the accuracy is also improving, and this is about the aneurysm, the bulging of blood vessel. Suppose we doctor fails to detect this kind of bulging of blood vessel or aneurysm, then it automatically ruptures and then patient will go for a coma. Okay, and then detecting that is one of the crucial things. And then this is about the COVID signature. So this is the CT where you see these are all the COVID signatures what you see, and this is how the consolidation appears. Okay, so detection and quantifying is one of the important aspects. And then also track that over multiple time points is also another crucial. Okay, overall the series supports the radiologist to improve radiology, just improve accuracy. It can be only a secondary reader, and then the readability through multi-reader and multi-site is another crucial. So that's about my talk. If you have any further questions, I'm happy to take reflections. Go on for the discussion.
Any questions from audience?
No question, please. At least two things. So I went too fast, or I don't know whether I'm able to convey the message properly or not, or is it too high for you people?
Can I ask you?
Sure.
How serious we are with respect to GDPR in India?
Yeah.
Is there any awareness, or we are?
Good question. Actually, recently in Indian Parliament there is a medical bill passed, the protection, where they have earlier they had drafted the medical bill, but that was too tight. With that, we were not able to do any research. Suppose by chance if data leaks, the data provider should have gone for child or something. It was too stringent. Now they have revised it, and that is happening in the it's going on. Not that awareness is there in India now. I think they are really passing it on. It's in the parliament.
And you have some inputs to, most of them are students here. How cautious they need to be with respect to data.
Yeah, so we see, one thing you need to be very careful is whenever you are using the patient data, make sure data is de-identified with respect to the personal health information. So make sure there should not be age, name, patient name, all those are de-identified. There are already some of the open source de-identification tools exist. So make use of that and do the de-identification and make sure all the PHI information is removed, and also look at that clause before using the data, whether that is usable or not usable, whether there are different clauses, go through the data clauses and then use it in your experiments.
Yeah, it was a good presentation. Very nice input was provided. I have a small query regarding federated learning. How is industry facing for federated learning? Has it come as part of the product, or how is it going?
Yeah, that's a good point. Actually, we have a cloud solution as a product. So in that cloud solution, we have already integrated this federated learning in the HSDT platform. We have a platform called L-Suite platform where it is already part of it. And we going forward, we use this for the validation of the models.
But federated learning has to go beyond cloud. Like we want to get rid of limitations of cloud. So how that Is there any, standardization is happening in that direction?
Yes, very important point what Professor Manohar is bringing in. The privacy aspects are very crucial. So see, for example, when we really uploading the data to the cloud, there are always chances that it might get leaked. Like how do we really make sure that it is encrypted? That's why there are already the algorithms available, privacy preserving models. So PPDLI we say. Okay, we use PPDLIs and then PySeed. Those are all the models that are already available, libraries already available. We are using those framework, and then if there are any gaps, we are also modifying those, and then we have our own in-house privacy preserving aspects.
Thank you.
Thank you.
Thank you, Dr. Dinesh. I think there is no more questions. It's a wonderful presentation, very simple for students also to, grab some of the points. I'm sure they have learned a lot. Thank you once again.
Thank you, sir.
I thank Dr. Dinesh MS for his informative words. I now request Dr. Manjunath sir to present a memento as a token of gratitude to Dinesh. I also thank to Professor Karunakar Kotegar for his presence. I request Dr. Manjunath sir to present a memento as a token of gratitude. Thank you all. Now you have tea break till 12:15. Then we'll move on with the panel discussion.
Now we have arrived to the most interesting part of the ICDAR 22, that is panel discussion on the theme Future of Data Analytics and Learning. On this occasion, we have with us the dignitaries for the panelist as well as the moderator. I request the moderator, Dr. T.S. to escort the other dignitaries onto the dais. Dr. Annappa, NITK Suratkal, and Dr. Murali S, and Dr. B.H. Shekhar, Dr. Radhika Pai, and Dr. H.L. Shishireka, and Dr. Bharati R.K. Thank you, sir and madam. I just go through the brief bio of each panelist first. The panelists are Dr. Annappa, the professor, NITK Suratkal. He is having more than 30 years of experience, and his research areas of cloud computing, big data analytics, and social networks and machine learning. And already he is guided 6 PhD students and guiding 8 PhD students under these research areas. And Dr. Murali S, the professor and president of Maharaja Education Trust, Mysore. And sir is having more than 30 years of experience, and his research areas of image processing, pattern recognition, data analytics, and he is having more than 10 research scholars, and he already guided. And Professor B.H. Shekhar from Mangalore University, and working in the area of image processing, machine learning, and many more related areas of image processing. And he already guided 15 PhD students, and currently guiding 12 students. Dr. Radhika Pai, the professor and head of ICT, the Manipal Institute of Technology, Manipal University. And madam is working in the area of machine learning, image processing, and data science. And Professor H.L. Shishireka madam, the chairperson of the Department of Studies, Mangalore University, and working in the area of natural language processing, and already guided 4 PhD students in the same area, and guiding 8 such students. And also with us, Dr. Bharati R.K. Madam, Professor in the Department of Computer Applications, SJC Mysore, and Madam is working in the area of biometrics, and in particular biometrics, and also the image processing and machine learning related areas. And the most important part of this, the moderator of this particular theme, Future of Data Analytics, the panel discussion, Professor Guru B.S., the Department of Chairperson, Department of Studies, Computer Science, University of Mysore, is agreed to be the moderator of this particular panel discussion. He is also a general chair of this particular conference. He is having more than 35 years of experience and working in the areas of data analytics, machine learning, pattern recognition, AIML, and he already guided around 19 students, and 6 students are currently working in the following areas, and his publications is the journal publications of 85 plus, and also 300 plus conference papers is having. With all this brief information, I would like to welcome the moderator and the panelists of this particular panel discussion, and also the audience of this particular conference. Now, I would like to request to Professor Guru sir to take over for this particular panel discussion.
Thank you, Professor Nagina, for having got every one of us introduced to the SPRK. So, good afternoon, everyone. So, hope you are all active. In spite of your notice that all of you were looking at your mobile phones when others were speaking on the dais in the morning, including your paper presentation system. So hope that you keep your mobile aside, don't look at the mobiles. These are the experts who have been working on not only in data analytics in general, but also mobile data analytics. Probably you can raise a couple of questions for the experts who are on both sides of me related to your problems in handling used data coming in through mobile devices, right? So I appreciate if you raise a couple of questions for the panelists so that you can take up that problem for further exploration either as part of your master's thesis or bachelor's thesis. So I'm happy to have 6 experts who are known for their own contributions in their respective domains. Initially, I just interact with them with one or two questions to see that you get to know about each one of them, and then I just expect you to interact with your own doubts or points for clarification, whatever. So, good afternoon again, once again to all of you. So, just we heard of Dr. M.S. Dinesh, who had given a wonderful presentation on solutions for healthcare related problems. And probably though I was able to ask a question because he was rushing through the city Bangalore to get hold of his bus to Mysore, I did not like interrupting him. But now I have a panelist here, one among these panelists, who worked extensively on image data. And my problem was to link with that previous presentation is, though most of us are interested in taking for work related to medical data analytics, but finding out the data related to medical images and meeting with the radiologists and getting them labeled to work on machine learning. So what is really required for machine learning is the use of data, especially to train deep learning architectures nowadays. So I have a panelist, Dr. Radhika, with us, who has contributed towards the creation of a data sets, especially for healthcare related activities. Dr. Radhika, my concern is what are the challenging issues to come out with a relatively a big corpus so that I can train up my model for my healthcare domain.
Good afternoon. As suggested by Dr. Guru, we are working on the medical data sets. So we are working on the type identification of vertebral column fractures. So you know that vertebral column is the main structure of a human body. So there are several bony structures. So the fractures may occur at any point in the vertebral structure. So these vertebral structures, there are different types of fractures. So it's not just, according to us, it's just a fracture of a bony structure. But there are different types depending upon the type of where at what point the fracture has occurred. So based on that, we have type A, type B, and type C identification. So the doctors normally, what they do is, in order to identify the fractures, they go for CT scan. So here we are going to take the CT scan images in order to find out what is the or where the fracture has occurred. So as you know, the CT scan images, the doctors have to go. It is not a single image. It will be like as you may be aware or not, the CT scan you have it in slices. So there are multiple slices for the same bone structure. So the doctors have to go through all the slices in order to find out and locate which slice that fracture is clearly identifiable, and then have to identify the fractures. So that's a decision which is to be taken, which takes longer time for the doctors to find out where the fracture is. So here we are going to develop somewhat a decision support system for the doctors, so that the doctors will be able to identify the fractures in a minimum amount of time. So for that we are going to develop an automated system based on deep learning models for type identification. So for that reason, as you know, the medical, whatever we are going to do on the medical data, the availability of the data is a major problem. Here, since we are working in MIT and we have a hospital attached to our university, we are collecting the data from the hospital. And again, for collection of the data is not a simple thing, as told by Dr. Dinesh in his the data. And one more thing is we have to get the ethical clearance from the committee. We have a committee in the university which has to approve that collection of the data. So in that way we have collected some 400 to 500 patients' data in order to identify the type of fractures in the vertebral column. Right. Now once we have collected the data and we are, as you know, different models are existing, or we can have develop our own model in order to identify the fracture. But how will you validate that your model is performing well? So for that we need some ground truth. So ground truth from where do we get? Again we have to go to the doctors. So we have to, the doctors have to annotate the data. That is, the doctors have to find out what type of fracture is present in. That is, again, it's a tough job for the doctors to provide us the data, because it's not just all the slices of the CT scan data. The doctors have to provide in which slice that fracture is clearly identifiable, and then the doctors have to provide which type of fracture is there in that particular slice. So that way we have collected the data and then got it annotated by the doctors, that is our bone specialists. So, and one more thing is, as I told you in the beginning, that the identification of the type is a very tough job. So here, getting the annotation from a single doctor may not be sufficient. So we have got the annotations from 3 specialists. And again, as Dr. Dinesh in his presentation has said that there may be differences between the opinions of the doctors. So for that we have done some other analysis in order to find out, to come to a common conclusion as what type of data is this. And then we are going to apply the data deep learning models for that. So this is a brief description of the work which is currently going on. So the collection of data is a major part of the analytics on medical data. So we are going for CT scan image data.
Thank you, madam. Friends, you can mark questions. If you want to interact with her, you can later interact with her. Once first round is over with all experts on the case. What really matters, as we understood, is large data collection and maintaining that large, not only from a single geographical region, perhaps from multiple geographical regions. The tool which works wonderfully well for this Manipal or Mangalore region may not work wonderfully well in Madurai region of Tamil Nadu, and similarly it may not work in the USA. Can we think of some distributed environment where we can collect samples from across the nation, across the world, and see that all of them are respectively labeled by the doctors, and then put them into cloud for viewing, and see that the tool works in distributed. I have with me an expert who has been known for his contribution to. Come on. So I have an expert, Professor Annappa, who is known for his contributions to the distributed environment and cloud computing, making AI-enabled solutions deployable today. I want Annappa sir to highlight some of the challenges related to handling of big corpus in distributed environments.
Good afternoon, everyone. Thank you for this opportunity to share whatever little I know about this field. It's a vast field. Knowing about in and out of this field is really difficult. The question is, sir has raised how to generate this useful data. Again, it comes back to us being a teacher, good teacher, teaching for many years. How many of us wants our kids to become teachers? If I go and ask in my class of 130 students, hardly there will be single-digit students raising their hands, sir, I want to do PhD and join for teaching. But as a parent, I want my kid to be taught by topmost teacher in this world. If not in India, I am ready to send them to US, UK, wherever there are good teachers. Same concern here in medical data. Privacy concern. You may guess my age, you may guess my weight, or sometimes you may be able to guess my age. But guessing whether I have BP, I am diabetic, I have other medical ailments may be difficult to you. And I don't want to reveal publicly. So having this concern about data privacy, what are the solutions we have as on today? Privacy preserving techniques, there are many. Those who are working in the database and security area, they will be working in this area. Recently, in machine learning, there is another field called federated learning. Two of my research scholars are working in that area. The idea here is, so I want to consult a topmost doctor in this world for my medical problems or my relatives, parents' medical problems. But how can I share their medical data without worrying about privacy concerns? So there are solutions coming up these days. We are working on federated learning, a techniques where data resides in the location where it is captured or where it is gathered. The researchers around the world, whatever their machine learning models working on this data, can send that machine learning model to the machine where I stored my data at my institute or my home. That model will come to my system, work on the data privately stored in my system, then send the updated model back to the researcher somewhere in New York or USA, UK, anywhere in the world. Like that, the doctor doing this research or engineer doing research on medical field in association with experts, doctors in this world, can get the patient data around the world. They can send their model to various locations around the world simultaneously. They can operate on this data, get their machine learning model updated, consolidated data without worrying about the privacy concerns will be analyzed by the doctor somewhere sitting in the world. So here, using federated learning, the privacy concerns are addressed effectively, and any patient or any doctor doing research in this area will be able to get the data without any worry. So the only thing is, the researcher or the patient should be able to store their data. Maybe all the patients will not be able to store their data locally in their patients. If they go to hospitals or medical research institutions like KMC Manipal or PK Institute of Research, Bangalore, their data can be stored locally with whatever privacy concerns. You may be knowing Government of India is coming up with a big project of electronic health records of any person in India. If that comes true and if it is implemented properly, your medical records can be accessed, analyzed anywhere in the world. Suppose you are traveling to US and you have some medical problems. That doctor may not be knowing anything about you. Just by giving your Aadhaar number and accessing the data and giving access permission to the doctor at USA, he can get the full medical history of yours, get what is required for him to give you personalized medicine at that moment, maybe within few minutes. Otherwise, doctor has to ask you, you will not be in a position to tell what is your medical history to the doctor, and you cannot remember what medicine a doctor, a family doctor gave you 6 months back, a year back, how it was working to you. The medicine what doctor gave to me may not work for you, may not work for other person, it may be giving a lot of reaction to you. That details may not be available instantaneously for the doctor. if this EHR project becomes successful, any doctor, treating doctor, can get the details of the patient without worrying about the privacy concerns and analyze your data within few minutes. So in the days to come, I think this medical data will be available to whoever working on this area, if not freely, for a nominal charge, maybe the hospitals and medical organizations who are curating this data. For their purpose, they may be charging nominal amount for the researchers who want to use this data. So with this lot of data available, the research can flourish and we will get good treatment and our human life will be longer in the days to come. With that,
Thank you, sir. Now we have Dr. Bharati, who has contributed in interesting modalities, interesting methodologies to make cost-effective devices for biometric applications. Madam, I just a word of you recently have conducted even a technical development program to train people on how to come out with some cost-effective devices for biometric applications. I just want you to be short and brief on some highlights to the audience to raise questions. Don't take a longer time.
Thank you, sir. The respected dignitaries on the dais and after the dais. As sir said, we are looking upon the development of low-cost devices. Now we heard lot of data is needed for the research, and huge data is needed for flourishing the research and so on. But when it comes to storing the data, retrieving the data, where do we do that? What is the cost incurred for storing, retrieving, or handling the data? Cost not only the terms of rupees or other things. What we meant was like the cost in the terms of the speed, accuracy, and so on and so forth. So it is very important today because as Guru sir in the initial beginning only he said that all the students are, many of us are dependent on the mobile devices. And every day our day starts with the face recognition in the mobile or our thumb impression on the mobile. So there comes to biometric traits which is already been deployed into our mobile. And now sir said like once the Aadhaar number is given to any of the doctor, you need to know the full history of the patient and give the medical data over there. So how does all these can be incorporated effectively and efficiently with less amount of time, increasing the accuracy, and in the devices where the common people can use it also. So wise the experts can also handle it very efficiently and effectively. So I'll come up again once all the panelists complete their talk and relate how that can be again related to the low cost with respect to the development of device and algorithm. Thank you, sir.
Thank you, Madam Bharati. So, yes, of course, I am ready to take up a problem and I collected the data. I want to come out with a low cost device, but who will sponsor it, right? What really matters is the financial support and looking for the schemes of government of Karnataka, government of India, or any international collaborations. So we have with us Professor Shekhar, who is known for executing a couple of interesting DST sponsored, UGC sponsored, interesting international projects. I request Dr. Shekhar to give some highlights on how to get good financial support from and what are the different schemes available in government sectors for budding technocrats to explore the countries.
Thank you, sir. Thank you very much. Definitely funding is the major issue. You need to have a good finance to carry out any work. I'm sure that's one of the major limitations that we have seen, and having the good infrastructure. In that context, the government of India, government of Karnataka, and also the international organizations provide funding. And it truly depends upon your calibrations, particularly on the kind of project which address state-of-the-art problems. So therefore, identification of the problem would be more important, and then the possible solution that we could provide. So when it comes to government of Karnataka itself, we have what is called as the VGST, Vision Group on Science and Technology. So every year they used to give a call for proposal, and it is possible to, and there are various levels for academic process, and they can establish a lab where they would grant around 60 lakhs to establish a project, develop the laboratory or an infrastructure which would help the researchers to carry out the works. On the other hand, there are also grants, seed grants that they would give to the youngsters who are in the age of maximum age 35 years and extendable for at least 40 years, where in which they provide 5 lakhs seed grant, and that definitely helps for them. And in that case, your project proposal matters a lot. What basically the kind of equipment that is required and journals that you would like to supply, and the solution that you are going to provide, which is supposed to be the state of the art, most important. Similarly, there are various levels, different kinds of projects, and also for the workshops of these kind, they will also start. That is at state level. So relatively, when you go to the state level, the competition is within the Karnataka region. Therefore, in that context, it would be, and it is for all engineering colleges, the universities, private universities, all are eligible for this. And if you go next higher level, it is the Department of Science and Technology generally provide the funding, and they have a lot of schemes. So one such, and every 6 months there is a call for proposal in DST for a project which goes up to 80 lakhs also. That is the amount of funding that we put. And for that purpose, you need to have a regular position in the university or in the private colleges also, sectors also it is possible. And for that, again, it is going to be evaluated by a program assessment committee, and evaluation is purely based on the kind of problem that you have taken up, and also the work that you have carried out, and the problem which addresses the local needs or the global needs. So probably preference will be given to the problem which really addresses the societal needs. So therefore, identify, and then the literature review that you are going to provide should be the state of the art. And your publication record should be good enough to fetch the project proposal that took from the DSE. That's at national level. Similarly, information communication technology, MIJAR is there. And then if somebody is working on, let's say for example, related to agricultural field or say, remote sensing area, so there also that is oceanography. Those kind of problems are quite interesting. And there are agencies, Ministry of Earth Science, so they provide a lot of grants for these kind of, and also Medical Council of India recently found out, and many people are working on that area. So also fund, and apart from that, of course, it is the AIET also provides the grant. It is needless to mention, and I'm sure many of you have explored those avenues. And the UGC. So recently, UGC has stopped funding, but AIET is still providing the grants for various schemes. And next to that is the international funding scheme, where you can invite experts, you can visit other places, and there are nearly more than 50 countries are signed an MOU with the Department of Science and Technology to execute a collaborative project. And generally, this collaborative project is of 2 to 3 years duration. And the grant covers your travel expenses from both ways, from either parties. And we need to identify a resource person on the other side who works in your area of interest and write a good proposal, most important, and also identify a good resource person, because again it matters a lot. And while identifying a resource person and also the institute, it is the QS ranking, NIF ranking in India and then QS ranking outside India would matter a lot. And also the quality of the works of that particular professor whom you are identifying also matters a lot for us. So identifying such people is the first stage, and then establishing what kind of problem that we need to. And it is a course of nearly 4 to 6 months to complete a project proposal.
So you have to be prepared for that. Firstly, you need to look for what are the areas of call for proposal, and based on that we can submit a proposal. Either to conduct a workshop or to execute a collaborative project. These are the various avenues. Probably we research in DST, gov.in. Thank you, Mr. Speaker. Very rich information you have shared with us. Generally, in Indian scenario, especially in academic sectors, we do wonder research, but we end up publishing in the form of papers, either in conferences or in journals. We are known for it, but most of the times we don't make up our mind to file for a patent. But today we have a personality, Professor Murali, who is the director of Maharaja Research Foundation, who has been successful in pushing through, inspiring his faculty members, his researchers, and pushing through more, at least a dozen of works for patenting recently. I request Dr. Murali to just highlight on the process of patenting and why generally we don't make up our mind for patenting research outcomes and so on.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Good afternoon to all. India is known for gurus. I mean, there is a difference between guru and the person who sits in leadership. If a teacher learns something, his immediate thinking is how to pass it on to students, how to pass it on to community. Always he thinks, another one to when we learn something, actually we always try to give it to the public. That, I mean, our immediate target students. Whereas if you look at industry person, if he learns something or if he devises something or he develops something, actually, his first thinking is actually make it a copyright and make it a patent. So this is the thinking. Nevertheless, now there is lot of thinking by our academicians also to get into patents and file it and get it. As long as it is connected to industry, which is executable, which can be developed as a product, it needs to be protected, patented. Otherwise, if it is just a kind of publication that we do, obviously if it is protected and nobody can just follow it, actually it is going to be waste. So therefore, first of all, we have to make a distinction whether it is really executable or to develop it as a product, then please go for patent. If it is just a kind of research to make an analysis of some data, like how we do it usually for the thing, then please publish in the conferences like this or they go to journals, kind of things actually. But now in India actually, as Dr. Guru said, a lot of people are going for patents. We too submitted for a lot of patents last year and we got around 17 patents in our institute itself. It is very, very simple. Portal is there in the central government. Download the form, submit it. You can do by yourself by just paying 1,700 rupees. That is only the cost. Just pay 1,700. Those who are sitting students, you are doing your 5-year project. You can make an attempt. Prepare the project report. There is a format there itself. You prepare the project, prepare the, fill up the form and submit it to the central government. But there is a difficulty. What is the difficulty? The format by which you are submitted may be, may not be the sentences that we use, or the work which is you have represented would have been done by somebody else. So obviously they look into this. If you are submitting for the first time, please go with the attorneys. There are some attorneys available in the website. You can just find out them and use them, but they charge. But if you don't want to get charged like huge amount, you can pay. Do the patent filing by yourself by paying only 1,700 rupees or 2,000 rupees or so. Now AICT has even giving 50% of that money to you if you are a faculty member. Even students can also do that actually, provided you feel that it is something different from others. If it is already been done by somebody else, they will never give that. Indian patents are available, foreign patents are available. Please try for Indian patents. So therefore, at least whatever that we have learned, it is there in India. Thank you very much, Guru.
Thanks, Dr. Murali. So, in Indian scenario, especially when compared to boys, the girls are performing better in most activities, especially in academia. Girls are in female pursuing research, especially is a tough job. because generally the women have got more responsibilities and there are some traditions forced by the parents, from the family and so on, right? In spite of it, accomplishing great research is really interesting and appreciable. We have with us Professor Shishireka, whom I have seen, filling a PhD, putting great effort, taking care of families, teaching in universities, attending all. I just request Dr. Shishireka to use a couple of interesting, encouraging words for the female participants here so that they can make up their mind to take up a research.
Hello, Namaskara. Thank you, Guru. I think this is the second time I am talking on the same topic. When it comes to ladies, we have more challenges. We have more challenges than men. Yesterday I saw one reels or a short video wherein the woman, she keeps something in the oven and sets a timer, and before that timer, that time elapses, she removes the clothes from the washing machine, hangs it, then comes back, feeds the kid and does some other job, and finally picks whatever was in that oven by that time. Next was the turn of the man of the house. He keeps the same thing or maybe a similar one in the oven, and he is standing in front of it to complete the task, right? And I think all women and also all men, if not for this, agree for many of the tasks like this, because most of the time women are multitasking. I do not say that men are not multitasking. Maybe by the societal or by the practice that we are brought up and we are in. So the more responsibility is on women when it comes to family, right? And coping up with the family and also the departments, the work pressure, it's little tough. But what I feel to say is, we are also stronger than men, right? And we can easily share that responsibility. And I would like to say that when I can do, any girl here or any woman can also do the same thing, right? So this is what I would like to say. One more thing I would like to say is, why should we compare with men? No need to compare with men or no need to compare with anybody else. So what was you yesterday? So can we be a better version of ourselves? So if we focus on that, definitely we can do wonders. Thank you.
So one round is over. Now the experts are ready to take up your bullets in the form of very questions. Please, you can raise any questions to the experts, not to me, please. Yes. Anybody who can help? You can pinpoint even a specific expert if you are particular, otherwise you can put a questions across.
Good afternoon to all. I have a question to Radhika ma'am. Ma'am, you told that you have collected a large data set to identify the type of fracture. Since it is a real data and to collect every type of fracture, you have to wait for that type of patient to come. So how long did you take to collect such large data set?
Actually, we collected the previous 3 years data, but as you have told, all types of fractures will not be available. There will be like the common type of fractures data set will be more compared to other types. So we have A, B, C, and in type A, we have A1, A2, A3. In that A1 is the common type of fracture which is seen in normal. So that way we have different types of and as you told, we have not collected very large data sets, so that's what the point I wanted to add upon. As I told you, we have collected around 400, 500 patients' data, but to apply the deep learning models, those data are not sufficient. So we are going for, because we cannot collect still more and then again get it be annotated, because that itself takes time that we have to look into the doctor's free time, because we are going through the doctors, and doctors should be available for annotating the data set. So in order to increase the data set, we are going for augmentation. So we are using the GAN model for augmenting the data set, so that the number of data set is used, so that we can give it to the deep learning models.
I want to add up one point over here. Similar thing happens in signature verification models also. Generally for deep learning or any of the machine learning algorithms, we need a large volume of data. However, in a real-time situation, when we go to a bank, we give not more than 4 to 5 signatures. And that too once in 4 years or once in 5 years. And the model has to be so efficient. Of course, human intervention is there in the bank. However, if it is completely automated, we need to build a model in such a way that the small data only should actively promote for the efficient verification and recognition of the person. And this is what I wanted to ask.
One observation, one question. One observation is, as an organizing person in the panel discussion, equal partition for female and male. Congratulations for that. Usually in scientific conferences, we see lack of presence of women. But here it is 100%, 50-50. Congratulations to Dr. Guru. And Madam said we should never compare men and women, because men are from Mars, women are from Venus. Both are creations of God for a particular purpose on this earth. We should compete with ourselves. Question to Guru sir is Murli sir is regarding patent. Because most of the time, even students here, they know that they do so many things in software field, but we all know that software, for that matter, cannot be patented. But software people can patent their ideas, which are unique. If you give some more hints on that, because there are several students, they may pick up some point and they can go for filing the patent.
Okay. With the experience of the previous year, actually, this time, we have submitted applications from our institute, from the students' project itself. Some around 130 projects were there, we have submitted, and out of that 35 were selected actually. It is surprise to us also. We thought it is not possible for students to submit the project, we got it actually. Obviously students can really think of submitting projects because you think this is already been done by somebody else and you are simply copying from some other source. Obviously the fellow from whom you have copied, if he has not submitted for patent, you are the one who will be submitting and you are the owner of that obviously for that work. So obviously don't worry about thinking that I am a student, I cannot submit. So this is one thing. Second thing regarding software, actually now they know that there is a clear discrimination for mechanical civil related kind of projects, and for civil for computer science there is a clear definition. They consider only your definition, your thinking and your flow diagram, your data charts, these kind of things. They don't really consider what product you are coming out actually. Even for computer science also, patents are available. You need not have to write the code for it actually. Your thinking can also be considered and you can also get patents. So obviously there is a greater chance for software students to, computer science students to submit patents.
So response to this observation, friends, there is nothing like distinguishing male and female, equally treated, that's general statement. But female contains male,
Yes.
And she contains he. SHE has a he inside, female has male inside, woman has man inside. Superset is female class, subset is a male class. Males are always covered, umbrellaed by female. Female doing research, contributing a lot, really a great support for the male community also. That's what I believe in. One more question from Sarojay.
Next question to Annappa sir. Sir, you told about better learning where a machine learning model itself will be sent to the location where the data is present, sir. So that's a good ethical issue. But what is the guarantee, or is there a guarantee that my machine learning model is not overseen or it is not copied in between? It will not be hacked or something will happen to my machine learning model. Is there a guarantee?
So you're
Because my technique.
concerned about the model, copying of the model or the data.
Yes, sir. Not by the person who is providing me the data set, but in between if somebody copies my model.
Hacking the model in between.
Yes, yes.
So when you're transferring the model.
Yes.
So for that you have to use various other information security techniques so that you can mask your model only at the destination site where data is generated. They should be able to unmask and get that model. So there are various other general techniques of information security that can be used. We don't need a special technique for masking or securing that model. I think whatever other models are available, that can be used for masking your model. And it's not a major concern in federated learning.
Thank you, sir.
Hello. Sorry, I'm late.
Before we take up that question to all audience, you need not find the question related to what they delivered so far. You can raise any questions of your interest. So one of us will take and answer to you. Yes, sir.
According to what Professor Annappa mentioned, it is generally called as the cyber attacks. There are different types of attacks that you could see, not only the model, even to the biometrics. People are tend to go for what they call as spoofing. So several methods that are already available, you can go through, definitely will get the idea.
Sir, I get one idea to write a paper, technical paper. My question is that whether I have to apply for first a good impact factor journal or for a patent first, which has to be prioritized. My question is, patent, somebody says that patent, some says you have to publish one good quality journal. Which is to be prioritized? This is a general question.
Probably I would like to take and then take chance because I experienced with this kind of problem. Initially, this was the idea coined by my guy Professor Guru sitting over here. The idea is very simple, but having a firm mathematical background. So it is to identify the lines in the given image. So generally we know that when it comes to a basic mathematics, say for example, we tend to employ large eigenvalues to be considered to analyze the data or to capture the most descriptive or what is called as complex information, hidden information. And we have used small eigenvalue, where in which the small eigenvalue associated with the straight line is approximately 0 because this digital line, the value is going to be approximately 0. And we could succeed in exploring that and able to develop a computationally efficient algorithm to detect a line in a given image, where in which people tend to use generally the O transform to detect the lines in the image. And once we could succeed in getting the results, good results, then I asked Guru sir, shall we go for publication in the conferences? He said, no, wait for a while. And don't be hurry, because it's almost 3.5 years for me when I started my research and doesn't have any publication. So generally after 1 or 2 years, couple of years, we have the tendency to go for the publications. Almost 3 years, 3.5 years are over. Then I was so much keen on publishing at least one in conference, because many of my colleagues come out with many journal conference papers by that time. He said, you need to wait for a good fruit. I waited, he said, and then we submitted to the Journal of Pattern Inclusion letters. So reviewing more than, to my experience, 15 to 20 times. So such number of revisions were made, giving a sound mathematical base for our argument. Because it is the argument is that mathematics is that simple computation of eigenvalue which is said to be approximately 0. How do you generate the theory, the hypothesis, and experimental results is the, the crux when you are designing a paper. So that's why it consumes so much of time, and subsequently we submitted to the journal. And we got a very good comments, so major comments, where in which they asked us to compare with the standard algorithms also. And for that, of course, which we showed to IIM platform and could able to get the results. Therefore, my request is, even though it's a delay in getting a publication, better to go for a journal so that the citations at the later stage is very high. That's what we are feeling now at this stage. Thank you.
Hello. I think your question is first whether to go to patent
Yes,
or whether to publish.
yes.
So whether you have to first go for patenting, because once you publish, if it is in the external domain, you cannot patent it. So first file a patent and then go for publication.
Okay, thank you.
Any other? Publication, if you would like to protect, you can go for copyright. Once you publish, if you would like to protect your publication, you can go for copyright. If your work to be protected, go for patent. See, once it is already published, you cannot go for patent. So that is why you need to first go for patent. Or you would like to publish it so that anybody can see it. If you would like to do that, then go for copyright. So therefore nobody can talk.
If I publish in a good quality journal, Scopus Index journal, it is already copyrighted.
See, there are many other ways you can do the publication. Go to this conference and do the copyright.
Sir, my question is whether I have to go for a separate copyright or if I publish one paper in a good quality.
90% of the journals they have a copyright of their own. Right? You cannot just have a second copyright on that. Whereas, like conferences where you are submitting the papers like this, actually, if conference organizers have not taken any sort of copyright, then you can go individually on this actually copyright by quoting this. My paper is published on so conference, it is published, so I am taking copyright for my own paper. Like that, you can just take it. It is possible.
Yeah, the material will be published in the form of papers. It becomes a copyright for the publisher. Like the proceedings will be brought out by the sprinter. All the papers will have a copyright for the publishers. But whoever makes use of your contributions, your model, will have to cite. That citation is in your citation. That is in your name. And that will not fetch you any revenue at all. But if somebody wants to take that material and pay for it, that goes to the sprinter, not to you. But the citation comes to you. That's what is called publication.
Added to this, to continue the discussion regarding the patenting issue, in that once that article is published, modification of the same is made by the same student Dinesh, who is working for the industry, and they submitted as a paper. Taking the application of aerial landing, the vehicle lane identification, they use that and project it as a problem, and they patent it. So that's the.
But in the patent documentation, your paper will be cited. Even the patenting documentation by the industry, there will be a reference where your paper is cited. Okay. Yeah. Let's listen to somebody.
Good afternoon all. Question to Naka. I think you are speaking about federated learning, sir. My question is, as you all know that federated learning needs to be deployed in the real time. There might be chances of getting a model getting deteriorated, right? That means it's called as a model drift. Deteriorating in terms of performance of model. Like how do we handle this model drift, and what is the frequency with which we are going to retrain that model so that the model is performing well over a period of time?
Model drift. To tackle that problem, maybe after several iterations at the site, you can once in a while you can send the model back to the main server, where it can be compared. Is there any drift in the model? That is one aspect you can look in. Or it can be collaboratively. I am doing in my system, you are doing in. We are collaborating. We trust each other. You got the model from the main server at 8 o'clock. I got it 10 o'clock. I started working on. At 12 o'clock, we both can share that model and compare instead of again going there.
And my question was, is there any current existing tools available for such a monitoring system, or is there any scope for doing that?
We are using the Clover model, but as of now, it is not there.
Okay.
You can think of inserting a module in that to do this.
Okay.
There is scope.
So why I'm asking because
also you can think of contributing there.
Why I'm asking because in our company we are developing such a monitoring system where we can identify the deterioration of the model by identifying the drift of the performance of the model, and also we are identifying the data drift where we can identify
data drift. Since your data remains at your site, if there is a drift, I think that particular site is responsible.
No. What I was mentioning is we are handling two kind of drift. One is the data drift, and the one is the model drift. I was supposed to ask only with respect to model drift. Thank you.
Look at the reverse engineering.
It's
already available. Reverse engineering concept.
Yeah.
Which is already available, well known in the domain of software engineering.
Okay.
That would very well suit.
Any more interactions? Yeah. I appreciate that graduates who are pursuing bachelor's of engineering.
Shashilata madam, you told that we women are doing PhD research and higher studies in spite of many hindrances. Nowadays, I think we are getting support from our family, from our spouse, but the hindrance is coming from the UGC itself, because the UGC has stopped giving FIP now.
Okay.
So,
FIP. I mean, what we can do is we can always think of whatever is under our control. Yes. Suppose if it starts raining outside, we don't have any control over that. So within our jurisdiction, if we can have a say, or if we can control that, yes, I think we can think about that instead of, whatever is beyond our control. But because, as a common man, I and you cannot do anything about UGC. Yes. Bharti, I have a small point to add. We have to prioritize, is what my experience is. Like, as first madam said, we have a lot of responsibilities or tasks to do. So, what best prioritization that we make, either on the daily basis, monthly basis, yearly basis, or the achievement basis, that would definitely help for us.
Yeah, and probably added to that, there are so many schemes available in the government of India, particularly to encourage women scientists. You can explore those arrangements to go outside. I think just now I listened Professor Karnakar Kotagar. His wife has got an option to go to Pennsylvania, but due to various reasons she couldn't move. But what I am trying to say here is not only to go outside of India, there are schemes available in Government of India to get the grants, not necessarily in FI. So I need to look for that. There are schemes, especially for women. Yeah, especially for women.
Sir, it's okay for full-time workers, for part-time research scholars.
no, you apply and convert your part-time to full-time. There are many schemes supported by the government itself, so that your government, Karnataka cannot say no for your application. The Karnataka government has to review you and put on a full-time, in case if you are sanctioned from central government. There are many schemes especially for women scientists. You have to look for it, explore that.
Yeah, DST.
And relaxation in age also.
DST supports travel, air fare if you are going abroad. That is once in 3 years you have to apply for that, and I don't know, all applicants may not get, but definitely you can apply for that. Not only DST, there are several private agencies also where you can seek funding.
I would like to add a point, madam. Couple of weeks before, I got one mail from some, especially exclusive for women.
Correct.
Great.
There are many.
scheme, one scheme, I was interested to apply. Then I was shocked to notice that it was only for women.
Any other points from budding technocrats?
Not only that, there are several workshops, there are several meter schools, ACN meter school is meant for women. Like that, many workshop conferences also are made for women to encourage participation of women in science and technology. Maybe, I mean, for part-time scholars, definitely you won't get FIP. Maybe you can try in this direction.
Added to that, to avoid the competition from IIT, Government of India, Karnataka, has proposed a scheme called State University from DST itself, so research funding. So you can also explore, because when you go globally, particularly at Indian level, lot of projects definitely go to IITs and IITs. Next is NITs, next is IITs. State universities, engineering colleges will always get it, even though your professional background is very good. I noticed that evaluation, maybe there is some which I cannot comment, but however, this scheme is there in Bangalore. It's for both men and women.
So, last maximum 2 questions. And before that, I request our panelists to be ready with one use cases related to mobile data analytics. Finally, just went up in a cycle way, highlighting one use case related to mobile data. Okay?
Sir, one observation nowadays, most of the undergraduate students, they directly go to deep learning because it is easy to implement and easy to do it. But nobody knows what happens deep inside the deep learning. But they are getting the output and they will close it. It may not be a good trend. What is your suggestion, for especially for undergraduate students, whether they have to start with, anybody who wants a career in AI, machine learning is a better way rather than a deep learning, because most of them we see, undergraduate project, they start with deep learning, they take one network and then they say that training.
Our experts got your question.
So please.
You want to respond?
So, indeed, I would say that this is the problem as faculty members we are facing. Because the moment we give some assignment or we give some project, students come and say we didn't find the code. That is one thing. The other one is deep learning, because it is a sort of plug and play mechanism. And not only with respect to deep learning, maybe even with respect to machine learning. What I suggest to my students is you start with machine learning, or even if you copy the code, you try to understand what it is. And sometimes I even remove some 2-3 lines from that code and I ask them to execute and show me the result. So understanding the machine learning concepts or using machine learning may give better insights into the problem, because first of all we have to understand the problem and then we have to think about the solution. So what I also say to my students is, keep the computer science aside, you look at the problem, try to understand the problem as a common man, right? Keeping computer science aside, try to see what is the problem and how you can get a solution if you are doing it manually. And if you can do it manually, then you can think of how to write the algorithm for that. This is what I suggest my students. Definitely what you said is not, students, I would say that they are not going the right direction using just this plug and play mechanisms. Thank you.
Added to your madam's discussion, also to your query. Generally, as you know very well, nowadays we all go with the deep learning models. Therefore, I suggest to any researcher or a student to understand the anatomy of deep learning. So you can ask them to give, or for a student to learn only the optimization algorithm, those who are interested in that, to learn only the loss functions, to learn only the convolutional neural networks. And later on, probably at the end, they can integrate and come out with the life cycle of a deep learning model. Not necessarily the existing architecture. They can explore into the database, local databases, and then can study every model that is available within deep learning. So that will one. For a researcher, we can engage definitely in that way, because they are going to spend nearly 3 to 4 years. We can ask them to study and report on all. But for the students community, it is time bound, maybe 6 months project. So in such cases, a portion of that could be given and later on it could be integrated at the end. That's what I feel. And
any other? So most of the times we the teachers inspire our bachelor's degree students to be more practitioners than designers. If we tune up our teaching towards making them designers rather than practitioners, perhaps this problem gets solved. That's my message to all of you. So now I request from this side to highlight one use case without much explanation on it, so that our budding technocrats can explore it as the project problem. Related to mobile data application.
So related to mobile data, one major concern is how best you can make use of use it for personalized personal growth. Like the mobile, it gives like what is your screen time, what was your screen time this week, last week, and what are all the contents that you have browsed or accessed and so on. So using that data, how best you can improvise your personality. So I want some of you to think over in developing the application where you can have the personalized personality development based on the usage of mobile, the content in the mobile. This is my question.
One thing is the mobiles you are using for various purposes, but some medical applications could be deployed onto the mobile devices, and that data could be used, that data could be sent to the doctor, and you can get the doctor's advice on your mobile phone sitting at home. So that is one of the applications.
Smartphone devices have contributed a lot to social media data, and you must be knowing how many types of data you have in your mobile. One social media, the social media data which is available, or the anonymity of the social media applications have given rise to a lot of generating a lot of hateful content, offensive content, hope content, all those things. So think before you post any message. Not only that, can you think of devising some applications where the moment you put something hateful content or offensive content onto the social media, that should not be spread further. It has to be blocked and thereby curb the spreading further. And this is a very useful application. This can be done in two ways. One is using the mono mode, like only the text, and of late we are having also the multimodal data, like where we have text and images. For example, hateful content with text and images, or fake content with text and images. And this is a very useful application because all the time we cannot expect the government and policy makers to help us. So this is one good contribution. Especially in Indian continent, we can say, because India is a multilingual country, and there is lots and lots of scope when it comes to text and speech with respect to multilingual countries like India. Thank you.
Students are very much fascinated with app development, particularly exploring the Android too. So therefore they can think of developing an app to understand different languages. That would be an interesting problem to the students completely. Those were app that can understand your local native language, which definitely is useful to the society. I am sure to solve many of the problems, because we are living in saying digitization, economic digitization and all those things. Can I develop an app which is useful to the farmer community or literate community and in their own language? So again, understanding your speech and also the text and also the language. So those three can be integrated and can come up.
Added to Professor Shekhar's suggestion, so AIET has come up with converting textbooks or material available in technical education to various local languages, including Kannada. So students can take up app development, which will, many times when I go to class, some of these students from, especially from North India, आप थोड़ा हिंदी में बता देते हैं, so it is easy for me to understand many of the complex concepts like pointers in the first year. They ask us to explain in their local language.
Many times it is difficult for us to explain in Hindi. Even though I can explain better in English, Hindi or their Andhra, Telugu language, Tamil, it is difficult for us. So if you can take up some project, people are from different states, say you are having NPTEL courses, take one course, maybe data structure or programming, try to convert that into the local language what you are specifying. That video with audio, if you can convert it to your local language, it will be a good help to your juniors. Thank you.
Since I am chairman of engineering college, I am happy to mention over here, before coming to the data analytic problems, in our institute we don't allow students to use mobile at all. Anywhere in the college campus, nobody is supposed to use. I think that is one of the things that you can really follow. It really distracts. Nevertheless, Dr. Guru, sitting on the panel, asked me to talk about one problem. Recently, we went to one flower show in Mysore. A lot of people, of course, rather than seeing through their eyes actually, they pick up their mobiles and shoot minimum 100 photos when they go to a flower show. That happens even when you go to functions, when you go to marriages and all, people pick up the mobiles and take the photos. You can think of, since it's a data analytic problem, people would have taken the photos from different directions. Obviously, they don't keep it in their mobile, they upload it to one of the social media, maybe WhatsApp, maybe Facebook or whatever it is. At least if not 100 photos, if they have uploaded some 10 photos out of that, each one of them, there are 1,000 people who are getting to this flower show or whatever show it is. And so many photos are there actually. You can think of taking up all this data, mosaic this, come out with a beautiful, flower show which is available maybe because it has come from different, of course it's a vast application, but you can think of, you can come out those who went to some marriage function, everyone who has captured this, images can be converted into a beautiful panoramic view of the scene. So that is one of the biggest data analytic problems that you can think of. Thank you very much.
Fine. So there are many other interesting use cases which you can think of building upon mobile devices. We just have highlighted only 6 of them. Because every day you are using and mobiles are becoming indispensable components of your activities. Whatever you face as a challenge, you think of. If you want to be a quick millionaire, you think of a very demanding mobile app from object operation. With this message, now I would like to conclude the panel discussion with a great acknowledgement to all my panelists, Dr. Burbi, Dr. Anupur, Dr. Thanks to all of you. Thanks to the organizers for having given us this opportunity to interact with you people. Thanks for the talk. Thank you very much.
Thank you.
Thank you, madams and sir, to sharing your experience on this panel discussion on future of data analytics and learning. I hope all of us got an information about this, and many of them are interacted very interestingly, as well as answered answers from the panelists also. Now I would like to request Dr. Dattatreya, Dean, Professor and Dean AIET, to give the mementos to all the dignitaries on the dais. Now I request Dr. Dattatreya to give the memento to Dr. D.S. Guru, the moderator of this particular panel discussion. Next to Professor Sheikh D.H. Shekhar. And also to Professor Annappa from NIT. And also to Professor Murali S.
I am very happy to say that this is a very bright moment for me. Sir is my teacher and I am doing my engineering. I thanks to Manjunath sir and that team providing this opportunity.
Thank you, sir. I also request Professor to hand over the memento to Professor Shashireka Madam. Also to Radhika, Dr. Radhika Pai Madam. And also Professor Bharati Madam. Thank you, sir. Thank you. Thank you, one and all. Thank you very much.
Back again, but I don't know.